Now you are aware that we have started talking about climate, environment, environmental friendly practices, but much of it is yet to be implemented on ground. So let's hear now what has Sameer got to talk about, the pollutants, why are they created, what is the solution to get rid of them, and how do we monitor the various kind of polluting elements. Over to you, Sameer.
Thank you, sir. So good afternoon all. Before I get into the presentation, just want to share one experience of not only mine, it's for applicable to everyone. I was in Mumbai till 99 and was into the frontline sales. Very frequently need to go to Pune for business discussions, business meetings. And before 99, on an average it used to take around 7 to 8 hours to reach Pune. You know, because of that traffic jam in Khandala Ghat. Then we saw this express highway coming in with the tunneling there. And that time from 8 hours, 7 to 8 hours came down to 3.5 hours. Now on an average within 3.5 hours we reach Pune. Okay. Now that missing link tunnel, once it is installed, once it comes in operation, we are going to save further time of another half hour over there on an average. Apart from that, now recently we executed this Rohtang Pass tunnel where I think 46 kilometers of the travel distance has been saved. The travel time of more than 1.5 to 2 hours is saved now. So this is not only helping us to reduce the travel time, but it is also helping us to reduce the pollution levels. It is helping us to grow our economy, commute much faster. So I am very, very thankful to the government of India, to the authorities, to all the EPC contractors over here, to all the engineering consultants and operation maintenance contractors. So they really deserve a big round of applause for them. Okay, coming to the topic, so we have the tunnels now. That's the theme, very nice theme, the need of the day. And we are seeing so many tunnels are getting built in India now. And when there is a tunnel, the question comes, is the journey safe to travel? And then so this is what it comes in. So these are the pollutant parameters. This is a typical pollutant parameter. We call it like the dust, is also known as the visibility. Now it occurs because of the incomplete combustion. It comes because of the friction. It comes because of the piston effect. When the vehicle movements, it's free floating dust, suspended particles in the atmosphere, that reduces the visibility. Similarly, due to the incomplete combustion, the carbon monoxide is a toxic gas, oxides of nitrogen are the toxic gas. The threshold limits are written over there. They are highly toxic. What should be the limit? Like typically when we talk about NO2, is 1 ppm can be harmful, and if it is less than 0.1 ppm is for the asthma sufferers. Ventilations and control systems are already there in the tunnel. But if you don't have the monitoring device, you cannot control that. So you cannot manage what do not measure. So measurement is necessary. Without that, otherwise the operation maintenance cost of the ventilation system is going to be very expensive. So when to run the fan, in which direction the fan should move. So this all wind speed and wind direction decides where. So this monitoring devices must be a small part of that entire project, but it's very important parameters to measure. These are like typical thresholds what we are seeing so far in many of the countries. So the visibility we generally talk about like around 600 meter visibility should be minimum maintained, has to be there. The carbon monoxide exposure limits like 50 ppm is 30 minutes exposure is okay, up to 90 ppm if it is 15 minutes exposure. Similarly for NO and NO2, the limits have been specified. Then these are the standard ranges what we see. The ranges are like typically for carbon monoxide 100 ppm, for NO 30 ppm, for NO2 it's less than 5 ppm, and visibility is like 0.015 meters square. So these are the standard typical ranges specified in the tender document, the tender contracts it comes with. And then now the question comes that the monitoring is must. How should we measure these parameters? So for gases pollutant, and there are different techniques to measure. So the majority or the broadly specified or widely preferred techniques are been over here, and I just want to give a brief about it. So one is the infrared measurement technique, which is like very proven, very rugged and reliable technology. It's been existing in the market for ages, for years actually. So where we use the infrared source and infrared detectors, and having a shelf life, there's no shelf life. The IR source can work as long as like more than 10 years, 12 years, so there is no deterioration. This is a technique where, you know, it's mounted across the path of the 3 meter is the separation between transmitter and receiver, the reflector. and so the path length is 6 meter. So we call it as a bulk measurement. So it's more representative measurement. Whereas another technology, which is the electrochemical sensors, it's like a spot measurement devices, very compact, easy to install, but then it has a shelf life. The shelf life is typically 1.5 to 2 years. So every after 1.5 to 2 years, we need to change the sensors, and because it has a shelf life, so it needs a frequent calibrations as well. But again, operation maintenance cost comparison, when it comes, then if you work out 10 years of operation maintenance cost, then the IR sounds still better, though the initial investment is higher for that. For NO2 measurement, now with the electrochemical, we can measure like, CO, NO, NO2, these all parameters can be measured together in combined, including the SO2 as well. Whereas with the IR technology, we can't measure NO2 to that low emission level because the level will be too low. It's like typically, as I said, the NO2 range is normally specified as 0 to 5 ppm. And to go down to 5 ppm, then the open IR technique cannot be used. So there then we have this blue LEDs technique, but then again, the NO2 has that specific LED wavelength has an interference with respect to the visibility. So visibility in the tunnel also is going to create the interference to the NO2, and to eliminate that interference, so we need to offer this covered path. The open path technology is not used. So the covered path means you could see the picture over there, and the gases are diffusing inside, and then the blue LED will be used for detecting the NO2 concentration with the detector in that. So this is a most preferred technology over the electrochemical cells as well. Similarly, for visibility, there are again broadly two measurement techniques are being used. So one is working on the light absorption technology, where we have the high intensity LED. The LED will transfer the light, reflector will reflect it back and falls to a detector. So when the light is traveling and getting reflected back, the visibility is not going to allow that 100% light to reach on the detector. So the amount of light transmitted versus amount of light received will derive the visibility, which we know that, okay, that's the coefficient we use, and on that basis we measure the visibility. So again, similarly, as I said about the IR technology, so again this transmitter and a reflector, or transceiver and the retroreflector, the distance is kept 3 meters. So it's like again the bulk measurement and the representative measurement over there. The second technology for monitoring visibility is backscatter. So in the scattering technology, what we use is the amount of light transmitted, and then the particles inside the tunnel will reflect the light. So that scattering technology has been used, and then the amount of light scattered, monitored by a detector, will tell you the visibility in the tunnel. Again, it's a like compact, very easy to mount. The beauty of that technology is, even, there many times it's the misleads. The misleading the visibility, is it because of the fog, or because of the fire, or because of some uncombustibles, so they are present in the tunnel. So that derives, and here in the laser source, there's a heated chamber. So that heated chamber will evaporate the fog, if any, and so the visibility is purely because of the particles in the tunnels, or because of any fire there. Then comes the wind speed and wind direction, because based on the inputs only the jet fans have been operated, the ventilation fans is been operated. So there are again two techniques. One is a single side wall mounted. Here what we use, the ultrasonic transducers are being used to monitor the wind speed and wind direction, and that sensor also comes fitted with the temperature transmitter, so it also tells you the temperature inside the tunnel. It's again a simple technique. There are two transducers, both are mounted opposite to each other, and then it sends the sound ultrasonic pulse, and one is against the flow and the second one moves from along with the flow. So one is resisting the flow and the second one is against the through the flow of the air, and because of that there is a time of flight difference, and that time of flight is derived on that derives the velocity inside the tunnel. So this is again the same ultrasonic, but then you saw that it's a single side wall, one side wall mounting device, whereas the other one is the cross tunnel. So in the cross tunnel, where like again the two transducers are mounted on the opposite side of the walls. Okay, so again it's a very representative and bulk measurement, but the drawback with this technique is it needs a wiring on both the sides of the tunnel, it needs the alignment, and especially if the large vehicles are moving, that creates the obstacle. This one is one device which is, we call it lux meter or luminance or luminance. So before entering into the tunnel or exiting the tunnel, the intensity of light needs to be controlled, so that otherwise the driver might get exposed to the black hole and he may suddenly apply the brakes, and because of that the hazard can happen. To avoid that, the lux needs to be, the light intensity needs to be controlled during the daytime, during the night time. So these are the sensors. We got all these ranges available in the product range. We got installations all across the globe, more than 1,000 installations we have so far. In India itself, we got more than 10 tunnels, and including now recently we got order from USBRL projects as well. So thank you very much. And we had a stall over there, so if you want to get the physical feel of the product, you are always welcome. Thank you, sir.
Thank you. Thank you for finishing on time. Ladies and gentlemen, you've given a very brief overview that today there are technologies and instruments available to basically monitor the gaseous emissions within the tunnel, the light conditions, okay, which we call visibility inside the tunnels, air velocity and direction across tunnels, and also the impact of light. When you enter the tunnel, all of a sudden you get blinded, and when you exit the tunnel, all of a sudden from a very low intensity light you get into very high intensity light. Again, the driver is likely to get affected by that, and how to control those. So there are various instruments available to monitor those, and also various measures available to cause that illumination, ventilation, and whatever is required, and whatever measures are required. We will not speak more about it. If you have queries, please go down to the stall and talk to the experts who will explain you your queries. Okay, next speaker is from Tata Steel, and the subject is advantage of smart fab, which is a Tata Steel product for the application in tunnel construction. And since your name has not been given to me, please take a minute.
Thank you, sir. Good afternoon, gentlemen, ladies and gentlemen here. Thank you, sir. My name is Prashant Kumar, and I'm heading this downstream business in long products, projects and solutions basically. So to start with, I would like to brief you about the history of Tata Steel in the reinforcement solutions. So Tata Steel is one of the companies who is into both long products, flat products, tubes, and many other solutions. So probably apart from doing the commodity trading, manufacturing some commodities, we are also into giving constructions, some solutions and services. So we started our product called Tata Tiscon Ready Build in the year 2008. Our first center in Bangalore, apart from doing the regular rebar manufacturing in the year 2000. Then we manufactured in the 2015 Tata Tiscon Ready Build 16 couplers, and then this welded wire mesh in the year 2017. So we are the only branded welded wire mesh manufacturer in the country. So our tagline is build smart, build easy. So a welded wire fabric typically looks like this: a rebar mesh in a slab or a floor maybe. But how it is different? It's basically a cold drawn ribbed wire or maybe a plain wire with electric resistant fusion welding. It can have square or rectangular grids in small diameters. So the advantage is the mechanical anchorage which is provided because of the electrofusion welding joints. So it is governed by IS 1566-1982, and the properties of the wire are governed by IS 432 Part 2 1982. Why I am specifying 1982? Because these both the standards are 40-year-old standards. So we have moved ahead anyway. Welded wire fabric, some people may be thinking that why not a rebar welding basically. So a typical microstructure of a rebar looks like this. The outer layer has a tempered martensite layer. A quick quenching makes this layer, which gives strength to the rebar. Inner layer is the ferrite pearlite layer, which gives the ductility and the flexibility to the rebar. When we do any kind of welding, we basically burn the outer layer, so that reduces the strength of the rebar by another 100 to 80 MPa. But with a wire which is basically cold drawn and then electrofused using resistant welding, the microstructure remains same, it does not change. So this does not deteriorate the property of the mesh basically. This is the reason we go with welded wire mesh. So this is a typical process of manufacturing. Wire is drawn by pulling it through a die, a reduction of around 0.8 to 1 mm diameter every pass, which increases the YS value and increases the UTS value as well. The percentage elongation though reduces, but depending on the application, the product can be used in different ways. Then depending on the requirement, it can also be ribbed, it can also be the plain form, and then it is basically electrofused, and this is a typical cross section of a this is a typical microstructure of the joint basically. So talking about the features of the smart fab, the product is available from 2 mm to 12 mm. I'm specifying 2 mm to 12 mm at interval of 0.5 mm. So this gives you a flexibility in the design. So wherein the minimum reinforcement is only 0.12% at times, we end up giving 8 mm 200 center to center considering the crack and shrinkage criteria. So that is basically wastage of steel. So if you have an option of designing certain sections which can ensure both crack and shrinkage criteria and give the minimum reinforcement, so this becomes an advantage basically. So from 2 mm to 5 mm, if the requirement is there, we can give in the form of rolls, and from 5 mm and above, it comes in sheets. So the sheet size can be any, but the width is restricted to 2.4 mm because of the production constraints. The spacing. So we give you spacing not in the intervals of 25 mm, but we can give you in spacing of intervals of 5 mm, multiples of 5 mm. So if you will ask Prashant, can I get something in 85 mm spacing? Yes, we can give you in 85 mm spacing as well. So what is the advantage? For example, in your design, you get a spacing of 196 mm. So what a typically designer does, he gives you spacing of 175 center to center and releases the drawing. So if 21 mm spacing is not considered, so you end up giving additional 10% of steel. But with this solution, you can space in the terms of both dia and also in the terms of flexibility in the distance. Further features, it gives you better concrete bonding because of the mechanical anchorage, because you can give the desired dias in desired spacing. That basically helps you, ensure both crack and shrinkage criteria as well. So it is very well defined in the IS 456, the splicing methodology. You have to give in cross wire spacing plus 100 mm. So this is, you also save in the terms of lapping as well. Typical process, you draw it, and if you want ribbed one, you pass it through the tungsten carbide dies, and then you straighten it, cut it into the forms, and these cross wires are placed in the machine, and they fall one by one at a specific interval, and you manufacture a mesh. So these meshes can also be bent. These meshes can also be sheared into desired shapes. For example, if you have a sunken slab, if you have a requirement of a ready to cast drains, typically you can easily do that using mesh. So smart fab in tunnels. So we have already supplied 54 metric tons of this smart fab in package 2, 80 metric tons in package 4, and 120 metric tons of package 6 of RVNL project. So what we have been doing, we have been supplying meshes for the tunnel lining. But there are other areas of application wherein this can also be used. The drains which run along the tunnels, you can easily use the bent forms of the mesh so that you can quickly do the castings of the drains. You can quickly construct the drains as well. Even the pavements, if you use CRCP pavements, then the construction of the tunnel can be expedited. So in areas and in typical season wherein you get very limited time to do the construction, this becomes an excellent solution. So in order to understand our smart fab, we have got a small nomenclature. We need to just define what will be the main wire spacing, what will be the main wire dia, cross wire spacing, cross wire dia, what will be the basically overhangs. So these overhangs can also be customized depending on the requirement. The typical cross section of the mesh is being shown here. When we do any kind of test, either in the transfer direction or in the longitudinal direction, we make sure that the product should not fail in zone 2, zone 3 and zone 4, which are basically heat affected zone and the welded zone. Now, weld penetration, it is very important. Commercially available weld meshes in the country, you can get weld penetration in the range of 6 to 7%. But in shotcrete application, wherein the aggregate falls at a very high speeds, it is an impact. So joints generally fail. So in order to make sure that these are, smart fab typically is not a product for fencing application, it's a product exclusively for reinforcement applications in the concrete requirements basically. So we ensure the weld penetration in the region of 10 to 15%. So we are available in rectangular or any standard shapes as well, any variable overhangs, considering if they have to go inside as a development end in a beam at the junctions wherein there are column and beams, we can easily give variable overhangs as well. So this product is absolutely customizable. So how are we better, or rather the industry has improved? IS 1566 1982, IS 432 1982 part 2, 40-year-old IS codes, and still the specification says that we should comply to IS 1566 1982, which says minimum YS value of 480 MPa and UTS of 570 MPa. But with rebar available in minimum YS of 550, We have also evolved with macro alloying and all those things. Wire rods have also improved. So we commit you IS complying to 1566, but properties matching to IS 1786 2008, which is property of FE 550. So you get better properties. So the longevity, the life cycle cost of the entire construction is better. Even in the terms of the weld shear strength, the IS 432 Part 2 says that it has to be 25% of the YS, but we commit you minimum 40%. So this is why this product is a smart fab welded wire fabric. And also, we're also trying to see that how we can use 5 mm mesh in the tunnel application. Reason being, 5 mm mesh can easily be used in the forms of rolls, means less time of application, less requirement of steel, and you can save a lot of steel in that form. We are available in 10 different locations across the country, and we are just a phone call away. Various application areas where we have applied this product is, of course, the concrete hume pipes, wall and roof production of the mines, slab and floors for the pre-engineered buildings, shotcreting for the tunnels, screed floorings for precast girders in metro projects, CRCP roads, floorings in warehouses, slab and shear walls in housing and commercial sectors, and precast reinforced RE walls in bridges. And recently we have done this project for, we are doing this project for L&T, for Delhi International Airport Limited, for trapezoidal drains. So we are providing them in 5 mm mesh so that it can be easily cut in the form of a fabric. The speed reduces, the speed increases drastically, manpower requirement reduces. So this is the typical RE panel of an NHI project. You can see the spacing. This varies from 190 in a single panel. It varies from 190, 140, 150, 160, 210 and 235 and so on. 2 typical panels. Likewise, there are 8 to 10 different kind of panels, and every panel has got different spacing. But can you imagine anybody doing it manually at site? A person who knows only inches, and that too, thank God he knows inches, he cannot do it in mm. But with a solution like SmartFab, wherein you can get solution in the multiples of 5 mm spacing, it is possible. The production speed increases drastically. So we provide design consultancy, we provide after sales support in the terms of placement drawings and all, complete supply chain solution starting from the raw material traceability and all, test certificate with each lot. It reduces the manpower, the construction speed is very fast, precision in terms of the quality and the spacing, and effective site management because there is no wastage. You only order what you want, saves your space because you do not need to do any kind of inventory management at site. Reconciliation becomes easy, and minimum winding is required because in a typical scenario, if you do a manual winding, you require at least 10 kg of winding wire. But in this case, if you are taking it in roll forms, you will require only 1 to 1.25 kg per metric ton. Or if it is in the sheet form, you will require only 1.5 to 2 kg per metric ton. So these are various areas wherein you can use this weld mesh. Actual supplies pictures. Even the,
may I request you to conclude?
Yeah, just 1 minute. Lighthouse project, all the different technologies used, even the tunnel formwork, precast 3D volumetric, component precast, stain place formwork, light gauge steel fabricated structures, everywhere the welded wire fabric is used. This product is very well defined in the CPWD DSR as well as hard drawn steel wire fabric, and these are the deliveries we do. We do a comparison of the existing design, that is the conventional design versus weld mesh, and then we give you the savings in terms of the percentage of steel saved. These are the images of the drawings which we have delivered, the mesh laying layouts, mesh schedules, how they have to be, even every detail of the mesh is given in that. We only need the GA drawings, design basis repos, load details, and the current rebar details to do a comparison. Typical case wherein we do a small case study with TVS Logistics. We saw that conventional TMT number of people required was 16 in a particular bay. In another way, wherein welded wire fabric was used, only 10 people were required. They worked for 8 hours. In this case, they worked only for 3 hours. So 128 8 hours were spent in conventional TMT. In welded wire fabric, only 30 hours was required. Total metric tons of steel used in conventional was 3.4, in regular, in welded wire fabric 2.3, 32% steel saved. So these are other application areas. So this is my contact number. In case if you have any queries, you can easily contact me on this number. Thank you so much, sir. Thank you, everyone.
Thank you. Right, ladies and gentlemen, I think it is quite self-explanatory. This is another way of, an efficient way of using the reinforcements. Nothing great about it. It is if it is in a precast kind of a situation, or where your profiles are very well established, known, repetitive, well, this is a solution that they've offered. It is definitely more efficient, more optimum. It saves your time, labor, cost, steam. He's claiming 30%, but if not 30%, maybe there will be certain degree of a certain percentage of savings. So I will not go more into it. Now I have two options. One is that since the allotted time is over, stop here, because now we are eating into the lunch and we will further eat into the next presentations. And there are 3 presenters left, and these are not interrelated. It is not in a flow. What we can do is that finish with the 2 technical sessions and at the end take up those 3 presentations. What do you say? The second is continue, eat up our lunch break, have 10 minutes lunch break and get back at the option is ours. So continue. Okay. My only humble request once again to the presenters, your products are beautiful. They are speaking for themselves. The moment you come and show up, I think it's a brilliant idea. Please do not read your slides. Okay, so present your product, don't read your slides. So next presenter is Mandir. Let's see how efficiently he does it. He's going to talk to us CAC products for underground construction. Over to you. Let's see the optimum efficient use of time.
Good afternoon, everyone. This is Mandar from CAC. I'll rush through the presentations and advised by the chair. I'll just cover the key points. Warm greetings from CAC. CAC basically is abbreviation of concrete additives and chemicals. We are primarily admixture manufacturing company, rather historically a raw material manufacturing company which used to supply to all global admixture manufacturers. Starting 2008, we forward integrated into admixture arena, and that is how concrete additives and chemicals was formed. Now we have state-of-the-art integrated manufacturing facilities along with R&D setups at 4 corners of the country, and we supply pan-India. We cover all the projects, key projects which are happening across the country, and with the growth story of India, we are also growing. Apart from India, we are also present in UAE. So we are manufacturing in RAK, and we are also a big supplier in Oman. So we would be very proud to say that we are an Indian MNC company, and now we are reaching out to more global footprints as the time comes. So we will have more territories, more geographies going forward. Specifically about CAC, if I want to say, with its parent company, we have about 75 years of experience in chemical manufacturing. So it is not just getting a raw material from a particular country, blending it and supplying it to the end user. We have in-house facilities not only to develop products in chemical sense, but we have the ability to have process development also. So all the equipments that we have or the factory setups that we have done, they are all indigenously engineered. So that is how we try to optimize the offerings, right from the equipments, the setups, to the formulations of polymer chemistry. That is where we don't waste any raw material, because X manufacturer of admixture would have 2-3 options based on his purchase ability. You would get the raw materials, blend something and try to give it to you. But whereas we go one step above, we engineer the polymers which go into the blend of the admixtures. That is where the optimization happens, not only on a technological level but also on a commercial level. That is why we are one of the largest in terms of quantity, the admixture suppliers as far as India is concerned. Of course, like I mentioned about the process optimization, even the logistics is something which we manage in-house, because you might be aware that we get chemicals in bulk form. So handling of these chemicals, if it is not done properly, can lead to contamination and subsequent deterioration of performance. So that part also we have taken care, and both the inbound and the outbound logistics is also manufactured in a particular standard, and these are deployed and monitored internally. Some of our products, we have hypofluid series, which is PCE based admixture. So this is just one nomenclature family of admixtures. We have a range where you have products, or rather the concrete makers would say they use it in grades M30 to M100, and we have regular water reducers, we have accelerated admixtures, and the family has a range of admixtures best suited to the other raw materials which are available in that particular territory. So now in India also, if you go to the four corners, you will have different cement, cementitious material, you have different sand properties. So you need to optimize not only the admixtures, but in our case we have optimized polymers for each territory. So that is how we can arrive at a best solution, techno-commercial advantage to our customers. Specifically to tunnel segment, primarily we were only polymer and then the admixture manufacturer. Now, but we are exploring more opportunities. We have seen deliberations in the yesterday and today that a tunnel per se segment is growing fastest if you compare to the global scenario. So we are also partners to this, and we have expanded the product range where we have shotcrete alkali-free accelerator, which is one of the biggest product volume-wise, category-wise that we have today. And we in fact not only supply the material and just forget about it. We also have systems where we can have installations on big project sites which permit us based on the volume consumed regarding ISO tanks which are heated. So these tanks help maintain the optimum temperature of AFA, which results into a benefit to the project where non-stop work can be done and there won't be any negative effect. Especially this is more critical in states like J&K where the weather is a challenge. Some of the other products, polyurethane grouts, polyurethane foam, we are also trading steel fibers. Basically, we are getting wires from a trusted partner and manufacturing the steel fibers at our end. We also are supplying microsilica. We have tie-up with global, rather specific Asian countries where we have a rich source of microsilica available. So each shipload is being tested before a dispatch, and we have batch-wise quality control at our factories, and then only the batch is released to the market. So it is not just getting a dump from some country and passing it on to the customers. We have sealants also, some capsules, cement and resin based. Some of the projects where we are already supplied and we are continuing to supply. These are all prestigious projects of our country. These are the approvals from our esteemed agencies, government bodies, the consultancy agencies. Some of the customers who we are supplying, these are all leading contractors of the country. Thank you.
Thank you for being so cooperative and short and sweet. And let me assure you, I think their construction material must be doing very well. Because they are so confident. They don't need to sell it so much and labor so much. He sold it in 5 minutes flat. So I bought it. Ladies and gentlemen, from reinforcements, we have moved to the construction materials. Jokes apart, construction materials or construction chemicals are an essential part, like it or not. Especially when we are operating under the inclement weather conditions. Most of the tunnels will get constructed in extreme weather conditions, be it the temperature, be it the humidity. And to control both, admixture is an order of the day. Only thing is, be very sure these should be properly tested and credentials checked before you start using it. But since they have, if you see, they have plethora of users who have already used their products in various projects. I'm very sure this is a successful project, a successful material. Please have a look at it. We can interact with them more. Right, now going into the next one. He set the stage very right. We have to invite now Varun on the modern rock support solution for the tunnels. So Varun, I'm sure you have taken a cue from your predecessor now.
Don't worry everyone, I know it's almost lunchtime, I won't hold you for too long.
No, great. 3 slides flat, yes.
Greetings, I'm Varun Kedia from Argentium International. Our company deals in rock support solutions such as self-drilling anchors, water expandable rock bolts, and four-poling solutions. So our company has been providing these rock support systems for tunneling applications for the last 30 years. During this time, we have gained vast experience in dams, hydropower projects, highway projects, and mining applications. During this time, we have faced many challenges, and as per our customers' feedback, we have continually improved our products, and we continue to do so. We provide only the highest quality products from the best manufacturers in the world, and our products are cost efficient and always meet the relevant international standards. So just a quick summary of the products I'll be presenting today. It's the Megabolt SDA, which is a self-drilling anchor. It's a Megapole, which is a four-poling solution, and the Megabolt ERB, which is a water expandable rock bolt. We also provide Mega Splice, which is a rebar coupling solution. So we supply products like rock bolts to create a self-supporting system within the tunnel. Users combine this with wire mesh, shotcrete, and concrete lining to cope with the different situations we face during tunnel construction. So what are the current problems with current bolting practices? I'm sure that most of us are aware with standard rock bolting practices. We are suggesting that there is a better, faster, and more efficient way to build tunnels. So the challenges with current bolting practices include the following. So first, the hole needs to be drilled by a boomer separately, and then we have to hope that the hole does not collapse. There may be a need to auger the hole. The consumables used in this process are very high. It's very labor intensive. There are safety issues like possibilities of rib collapse. A lot of manual handling is there. It's a very tedious process overall. So what's the solution? So we offer self-drilling anchors as a solution to these issues, and basically SDA is a rock bolting solution designed for unstable ground conditions such as sand, gravel, silt, clays, and medium fractured rock formations. These are most commonly used where there is a risk of the drill hole collapsing after pulling out the drill bit. Application areas include the following: slope stabilization, strengthening of existing retaining walls, foundations with micropiles, soil nailing, tunnel face stabilization, and temporary support anchoring. So this is just a very short video showing you how SDs are installed. So this is the self-drilling hollow bar, and this is the sacrificial drill bit. The drill bit is screwed onto the bar and then drilled into the tunnel. This can be done using your boomer. After drilling is complete, the faceplate and the nut are screwed onto the bolt, as you can see. And as the bar is hollow, a grout pump is attached directly onto the bolt, and the entire area is encapsulated with a cementitious grout or a chemical grout, depending on the rock classification. So what are the advantages? The installation of the rock bolt, as you saw, is much quicker in comparison to standard rock bolting processes, as many steps in the process are eliminated, and the load capability of the bolting solution is superior because of the combination of a fully encapsulated grout solution or a chemical solution. The value proposition: there is improved safety. The operator and the team is reduced to 50% less time in the tunnel area. Better productivity due to a reduction of steps. The bolting cycle time is reduced, reducing the cost of labor and associated materials. There's a minimal loss of shear resistance. No side fabrication is required, and you get better life from your boomer or drilling machines because 50% of the movements are eliminated. So the next product that I would like to introduce to you is the Megabolt ERB. which is the expandable rock bolt. Water expandable rock bolts, also sometimes known as Swellex, is drilled into the rock and expanded by means of a high pressure water pump. So that expansion of the bolt creates a friction and interlocking anchor. There is an immediate full length support and no need to wait for grout to set, and no chemicals are needed, only water, as you can see in figure 1. So basically this is simply a folded steel tube with an upper bushing and an inflatable bushing at the ends, as you can see in the photo. Applications of ERB type rock bolts include underground mining, road and railway tunnels, underground storage facilities, and other types of underground works like powerhouse, etc. The advantages of ERB is that it can take the complete load immediately without having to wait for any grout or chemical anchors to set. It can accommodate large rock movements and still maintain its load-bearing capacity. There's no need for grouts or chemicals, making the process much quicker, and it can accommodate for variations in the borehole's dia as well. This is a very short video on ERB application. If we can get volume a little higher, please.
Varun will have to conclude. I think you are showing everything that you have, no.
Just a minute long.
No, a minute adds everything, you know.
Okay, I'll be quick.
Yeah, this is understood now.
So I will just quickly conclude with our final product, which is the Megapole 4-poling system. 4-poling is a method of supporting weak roof of a mine or a tunnel used traditionally in soft, loose or caving ground. To make use of this method, steel tubes are driven into the ground before or during excavation. This technique of pre-reinforcing the ground ahead of the tunnel face ensures the excavation can proceed safely until permanent support can be installed. As you can see, the applications normally include 4-poling, anchoring, piling underpinning, water and thermal well drilling, site investigation and horizontal drilling. So these are some of, as you can see, these are some of the operational and economic benefits. Fast and carefree drilling, straight holes, no unnecessary flushing to the soil, and a quick setup time. This is how the basic technique works. I will skip the video, but please do come to our stall and see. We can show you, we have it on display, how the basic principle of this system works. These are the components used. Again, please do visit our stall. We can show you physically. We have it on display. And I will conclude with this. Thank you very much for having us over here. Thank you.
Thank you. Thank you, Varun. And without going into much ado about now, the last presentation, mercifully, Harinder. Yeah, he was very keen that he should also be given a chance, but he's a wonderful person. He's promised that he will not take more than a minute and a half. Lovely.
Hello, good afternoon everyone. Today I am here just a very little introduction of our company. The name is Ross Engineer. So can I start from here? Can you see that?
Can you switch on the presentation?
Yeah. So, France Engineer was based in Ludhiana in Punjab. So we are basically in this field from in 2017. France is the first Indian manufacturer of self-drilling anchor in India. So we are the first company who is manufacturing self-drilling anchor raw material in India and finished product in India. So in 2017 we have only one line for self-drilling anchor, and right now we have 5 lines in self-drilling anchor. SDA we are manufacturing SDA. Today our capacity is 55,000 to 60,000 meter, and post tensioning bars and pipe roofing is also here. This is the first machine we held in the company. So we are manufacturing R25, 32, 38, 51 and T76. So this is a CT bolt with the galvanization and epoxy coating. This is our press section. We are manufacturing plates, nuts and couplers. Fully threaded bars. Fully threaded bars also France is the first company in India who is manufacturing fully threaded bars. Some people know this is a hot rolled bars, and we have a collaboration with one rolling mill in Maharashtra. So we are manufacturing with the grade of 550 grade, 670 grade and 835 grades. Also dealing with the post tensioning bars for the launching and lifting bars. So we are also manufacturing the steel fibers, not a glued steel fiber but on the loose steel fibers. So this is a little video here. So now we have also one new product here. This is a DCB anchor board. This is called a double corrosion protection board. We are also supplying in Nepal and Ranko projects. This is a permanent DCB anchor board. This is also installation in Nepal. This is called CT board, corrosion protection board. We are also manufacturing a pipe roofing from the sizes of 76 mm, 89 mm, 114 mm. This is the expansion shell. The growth of the company, we are only 4 years old company. First we did 17 or 18 crore. After that 20 crores. After that 50 crores. Last our annual year is 50 crores. These are some approvals of national highways, railways, NHIDCL, customer approvals, and also we are working with the RVNL projects in Uttarakhand and Rishikesh also. These are our customers. We are also working with FCON, Terre Army, Buildcon, L&T, and ILS is now not here, also with the McAfee. So these are some projects. We are Chenani Nashri tunnels with ILFS, T9 railway tunnel, Jammu Kashmir with Venser, Chardham project with Bharat, RG Buildwell, McAfee and Namduga. We are also exporting regular export. We are in the Israel, Australia, Italy and Belgium and
Thank you.
so this is the just wishes.
This could have been faster. Thank you.
Thank you.
Ladies and gentlemen, you would have seen that, okay, this is a phenomenally fast growing company and one-stop shop. I'm very sure if you need anything, just tell them. I think they will manufacture it for you. So good, well done.
Thank you.
I won't take any more time. 9 presentations, each one very keen to take 20 minutes to be reduced to 10 minutes. I think it is a big task. So we finished in a little more than required time. So the presentation of mementos. So please invite them all. We will do that quickly.
May I request all the speakers to kindly proceed towards the stage so that we can have a quick memento
All speakers
presentation from
kindly come forward for receiving your mementos.
Please, everybody, otherwise Mr. Singh. Thank you, sir. And ladies and gentlemen, we shall now break for lunch and shall return in the next 30 minutes. The lunch break is for 30 minutes. Quickly, the next presenters, if you haven't yet had your presentations uploaded on the system, I request you all to kindly get that done first. And another reminder, please, if anybody has located Dr. Haral's lost belongings, please, if you can get in touch with him. He has been looking for it, his bag got swapped, and it would be a sincere request if you can once check, and if you find it, then please reach out to him. Thank you. Good afternoon, ladies and gentlemen. We shall soon be commencing with our next session. I hope all the speakers have uploaded their presentations here with us. If they haven't, this is a final call to upload all your presentations for the technical session 5 on urban tunneling, followed by our sixth session. The last session for the day would be innovative techniques. So all the speakers who are participating in either of the two sessions, if you haven't yet uploaded your files here with us, your presentations, please do, so that we have all the necessary data for your presentation when your turn comes. In the meanwhile, can I request everyone to now start gathering back to their respective seats so that we can now shortly commence the fifth session for today. And also, thank you everybody. We finally found Dr. Haral's bag, and he has all his important documents and things with him. So thank you for all the cooperation. And everyone can now please move towards their respective seats, have their mobile phones in silent mode. For our fifth session, which is on urban tunneling, we shall be starting off with that session very soon. And our last session for the day is on innovative techniques. Just a gentle reminder, if you have your presentations lined up, and if you haven't yet have them uploaded on the computer here, I request you to kindly get that done before your presentation starts, so that we have all the necessary data with us. And ladies and gentlemen, now that the lunch break is somewhat over, I request you all to kindly proceed towards your seats so that we can quickly start with our fifth session for the day. And like I always say, the sooner we begin, the sooner we'll end the session. So, ladies and gentlemen, our chair is already here with us, and our chair has taken his seat. We have Mr. Daljit Singh, who will be chairing the technical session 5 on urban tunneling. Before he requests the concerned speakers to line up for their presentations, I request everyone, people standing next to the stalls, people on the extreme right and left corners, please may I request you all to kindly proceed towards your seats so that we can start the session. Our chair for the session is already here in the dais, and for him to begin, we need to get the room in order. So can we please have everyone seated?
Good afternoon, everybody. I am Daljit Singh.
Ladies and gentlemen, can we please have a little less of
chairing
mama?
this session, technical session 5 on urban tunneling. I think everybody who is outside, they can immediately join, and those who are standing, please, they are requested to sit and kindly make a attention here. As we are again short of time, we are 1 hour, and as on date, in this session, we have 1 keynote presentation followed by 5 presentations. Means we are 10 minutes each for each presenter. Again my request to all the presenter to abide by the time which has been assigned for 10 minutes. There are 5 sessions. First, the key presentation by Dr. Chaitanya Jasti, Nilesh Pangavane and Shashank Surve. Then we have the first presentation of Vinogapuri Metro Station by Nitin Singh Rajput. Second one, construction of Kalba Devi Metro Station by MMRC in line 3. Then tunneling and excavation in Mumbai Metro areas, case study comprising of 5. Fabio, Palash, Ms. Maheshwara, Sandeep Kumar, Sandeep Singh and Sanjay Pajni. And then conceptual and practical approach to EPV tunneling in soft, hard and mixed ground by Arun Kumar. And the last, rising from the ruins, the arrival of the metro at Nabi Karim by Saurabh Sharma. Without wasting my time, my request, first presenter Dr. Chaitanya Jasti as a keynote presentation. Please come. Good afternoon.
Very good afternoon to all the co-professionals. So this will be a case study on the hybrid metro station which we are currently constructing as part of Mumbai Metro Line 3, that is Santa Cruz Metro Station. So post-plan session, I understand, but I'll try to make it as engaging as possible, yet completed in the time. Yeah, so I'll be taking you through the brief of Metro Line 3 and then the salient features of the Santa Cruz Metro Station and then the challenges which we have faced and how we have overcome them. So it's a 33.5 kilometer long underground corridor, that is Mumbai Metro Line 3, which is connecting the southern tip of Colaba and passing through the airport and other CBD areas, and finally it is reaching to Seeps. And on the day 1 of revenue operations, we are expecting a ridership of 17 lakhs and the completion cost is around 13,000 crores. And the subject station, that is Santa Cruz Metro Station, it is located exactly in between Kalina and Vakola junctions on the Western Express Highway, just butting to the Kalina-Vakola flyover, as we can see in the slide. And this is expected to be having a ridership of 75,000 on the day 1 of revenue operation, and it is also having the multimodal integration with road, rail and also to the pedestrians. And this is how a typical cross section of a metro station in Metro Line 3 looks like. We are housing both the lines, that is up line and down line, both in the station box. But whereas what is challenging in Santa Cruz station is you can see here the one line of this station is out of the box. One line of this station, one line of this tunnel is out of the station box, and this tunnel is connected through access cabins at regular intervals. We are having 11 number of access cabins in 250 meter length of station box. And this is how the cross section looks like. Here we can see there are multiple levels. We are having a plant room which is just below the tunnel level, and there are 2 plant rooms, one in the south and one in the north. And at the other locations where there is no plant room, the cross section is on the right hand side, where we can see the connectivity to the access cabin. And this is also the cross section in which we are having where we are having an entry exit which is opening directly 30 meters beyond the station box and crossing 8 lanes and opening on the western side. We are having 2 such entries which are opening on the western side, and these subways are connecting to the station box from the concourse level. And coming to the constraints, the major constraint in this station is we are just in between Kalina-Vakola flyover and 2.4 meter water line, which is a major water line for the city of Mumbai. The station is sandwiched between these two. If you can look at the narrowest location, this station is only having 1.68 meter of clear space available between the support system of the station box and the foundation on the western side, and on the eastern side, that is at the location of 2.4 meter water line, we are having only 0.66 meter left. So in this complicated situation, we have designed and executed the station with utmost safety precautions. And for this excavation and to implement the station box, we have developed 4 schemes of support systems at different locations. The 4 schemes are 2 at the shallow locations, which is having an infringement with flyover piers, and another one is having no infringement with the flyover piers. And the third is at the deeper locations, that is at the plant room where there is multi-level, and also the scheme 4 is at the poor geological condition in which there are around 6 grids which are falling in this poor geology, where we are having 3 levels of strike. So this is the scheme 1, in which we can see like this is completely with 2 piling systems, that is on the western side it is micropile and on the eastern side it is secant pile of 600 mm dia, and then the support system is only through the simple rock bolting. And here there are no infringement with the flyover foundations. In this scheme 2, we are having an infringement with the flyover foundations, and we are having 2 struts, 2 levels of struts, and then we are having soil anchors and then rock bolts beneath them. This scheme 3 is also same as scheme 2. The only difference is this is more deeper. This is having a plant room in addition. Here there is no plant room, here there is a plant room in addition. And coming to the scheme 4, which is the most complex, we are having soil anchors on the western side, pre-stressed rock bolts on the eastern side, and then we are having rock bolts beneath them, and then we are having 3 level struts. Earlier we were having only 2 level struts, these are 3 level struts. And just a glance on the construction methodology, what methodology and sequence we have adopted. Here we can see this is the existing condition where we have a Kalina Vakola flyover and the foundation is shown, and on the eastern side the 2.4 meter water line is shown. First, the secant piles of 600 mm diameter are driven, and then the micropiles, 2 lines of micropiles are driven on the western side, and then the capping beams, and then the first level of excavation up to 2.5 meter, and then the strut is erected, and then the upline tunnel is bored but not yet breakthrough, and then the second level of strut is erected at 5 meter, and then the third level, here we started driving these anchors on the eastern side and rock bolts on the anchors on the western side and rock bolts on the eastern side. And then the downline tunnel is also completed only in the station part but not breakthrough. And then since the upline is yet to be breakthrough on the T1 station, we have created a berm to maintain the overburden over the tunnel, and then accordingly this excavation is done on the eastern side with proper rock bolting. And after the breakthrough at T1, we have completed the excavation of this side too. That means we have broken the signals, and then rock bolting, and then further to the plant room. This is the third level, that is the plant room, and supported. And after constructing the plant room level, we have started opening the axis in the base slab level, and this downline tunnel is connected through these axis caverns, and then this TBM tunnel is widened using NATM. And how these NATM tunnels are constructed? So approximately 26 square meter finished tunnel is widened to around 56 square meter through NATM, and these NATM tunnels are supported with 1 meter spacing of lattice girders, and then initial shotcrete of 50 mm was sprayed, and then the second round of shotcrete of 125 mm with wire mesh, and another third round of shotcrete with 125 mm of wire mesh was done. And then the side support is through the conventional rock bolts, and the crown support is through the swellable rock bolts. And this is how the cross section looks like. So on the left hand side you can see the existing TBM tunnel, and then it is widened as the right hand side. So this was the situation. So you can see struts piling up, and on the right hand side is the NATM widening, and now the left hand side is the widened section of NATM, and the right hand side is the access cabins which are connecting between the station box and the NATM section. And I would like to call upon my colleague and Mr. Shashank to take over for the design part. Thank you.
basically design-wise, it is the same as other stations. When we construct the top-down construction, bottom-up construction, temporary work, second pile, micropiles. Micropiles we have used because there is a height restrictions. The major portion is Bakola flyover is very close. As Chaitanya say, 1.68. So we have to design a robust design temporary support system with the minimum displacement and settlement of the piles, then displacement of the piles, and even the displacement and settlement of the Bakola flyover. That we have achieved. Okay, some design assumptions as usual, nothing else. Only thing is there is a surcharge load which is 180 kilonewton meter square from the bridge foundation. Otherwise, remaining is all same than what we are using for the other metro stations.
Wrap up, please.
Okay, this is the one where we have got 6 grids from grid line 6 to 12. We got the man-made pits near the Bakola flyovers. That man-made pits then afterwards filled by some granular material. So that we have to take care. So here if you see, here the system as just Chaitanya had shown previously, there is a 4 rows of micropiles. Then it is supported by 3 rows of struts and 2 rows of 3 rows of struts and 2 rows of anchors for the micropile side. So this is the geology for that. So this is why we have done that. Explain. It is a 3 row strut with at +2, 0, -2, then 2 rows of pre-stress anchors. Other side there is a pre-stress rock bolt of 32 dia, then fully grouted rock bolts of 25 mm, 1.5 meter by 1.5 meter pattern. Apart from this, we have done a 3D analysis for the excavation support system. So what we have done, we have not model a full station. We have done a small part of the station where we have modeled the bridge piles also in that station to get the, because 3D analysis normally give a favorable result. So what we have done, instead of 2 struts, we have modeled 1 strut only, and we have done the analysis 3D with the sophisticated software. So basically this is the result: horizontal displacement, then vertical displacement of the soil nearby Bakola flyover, then this is for the horizontal displacement, this is vertical displacement, then this is the displacement for the pier foundation, piles for the pier foundation. So this is result of 3D analysis. We achieve this 3 mm settlement of ground surface only. Then deflection of pile is nearly about 4 mm only. Then deflection of open cut below the pile wall is 6 mm. Flyover pile settlement is 1 mm only. So that we have to achieve. That's why the system is totally robust system. Then horizontal displacement of flyover piles is 2 mm only. Then remaining strut and veiler design is same as we do for the other stations. So normally it's a 20 meter strut because station is 20 meter wide. Every 5.5 meter we have a strut. Then when there is a flyover pier, there we have reduced the distance between the 2 struts. Then instrumentation and monitoring. Instrumentation and monitoring, actually we have put real-time monitoring there. So all flyovers piers are monitored with the additional instruments like tilt meter, mini prism, target, vibration monitoring. So learning and conclusion. Actually the major learning is what we have done in this Santa Cruz with the RCC rings. So that can be avoided if we put the fiber reinforced ring. That will be very easy to cut, because I think most of the man-months is wasted in the cutting of the RCC rings. So that is a major learning we get from this thing.
Thank you, Dr. Chaitanya and his team. I think it's a good presentation. It's out-of-box construction, I can say. The construction between the flyover, just near the flyover. Just in the lunch session, I was discussing with Mr. Trivedi, who was the GM for this. He was mentioning that in this model, I think they have taken 0 settlement, but in actual it was coming somewhere 3 mm to 4 mm. That is also very good thing, I can say, because on the one hand you have to support 2.5 meter dia of water pipeline, and in between you have to support the I think they have provided rows of secant pipe, micro pipes. And second important thing what I have seen, as on date there is no codal provision for using the fiber. I think the first time they have used this in the segment. I think this is a good thing, and hope for you have put taken a lead in adopting this technology for the future also. Thank you. We have second presenter, D. Fabio, Palash Kachi, Maheshwara, Sandeep Kumar, Sandeep Singh and Sanjay Puri, Sanjay Patni. He is speaking on the construction of Kalba Devi Metro Station of Mumbai Metro Line 3. Major NATM works in congested urban environment. Who is the speaker who is going to make on behalf? May I know name? Who is the speaker for this? Sorry, I'm sorry. The tunneling and excavation in Mumbai urban areas case study. I think second presenter, this Kalabai metro station is not there. Is that you are there? I've been told you are not there. Innova Puri, okay. I think the Kalabai. You are there. Okay, I think then you can make it. But your name is not there. Who is going to present that? That's right. You can start. Your name of presenter was not there. Let's made a confusion. Sorry for slightly.
No issues.
He is going to make a presentation of construction of Kalba Devi Metro Station of Mumbai Metro Line 3, major NATM works in congested urban environment.
Good afternoon, Chairperson.
You are Mr. Dalvi. Okay, Mr. Dalvi.
Good afternoon, Chairperson. Good afternoon, everybody sitting in the hall. I am on behalf of MMRCL going to present one of the challenging stations of Mumbai Metro Line 3. And I believe in a forum like this, we are hearing about the Chowdi Bazaar of DMRC as a unique station. But I believe after listening this presentation, you will be add one more in parallel to Chowdi Bazaar as Kalba Devi Metro Station from Mumbai Metro Line 3 now onwards during such forums. So I am continuing with this. If you are Mumbaikar, you know better where is the Kalba Devi, and if not, you are aware of the Mumbai too much. So you are seeing on the screen, it's a very beautiful location. It's a Google map of Queen's Necklace, Girgaon Chowpatty, and from there 1.5 kilometer is the Kalba Devi metro station.
And Kalbadevi metro station is located in the busiest and congested area of commercial importance of Mumbai. And this station is an immaculate example of mega engineering structure being undertaken by Mumbai Metro Line 3, just near to the sea line and passing through only 9-meter wide roads. If you go to Kalbadevi area in a daytime, it is very much impossible to walk 10 meter in a straight line. You cannot walk in a straight line for 10 meter. In such an area, metro alignment is passing. You see on the screen. That's why the station has been conceptually planned for NATAM. Why the Kalbadevi station is required there? Because it will help and provide the direct access to the traditional market, which is hub for wholesaler buyers and commodities, sports equipment and medicines area. You will be get connected to the Kapad Bazaar, Dawa Bazaar. If you see the image, there is a scarcity of open spaces in this area. Normally the metros are planned on the government land or the land easily available by nearby. But this metro station is planned totally 100% on the private land. For that we have to acquire 12 private properties with around more than 200 PAPs, which we have to relocate and again resettle to the same location after completion of metro structure. Then we have to build the residential complexes, which yesterday our project director has shown the 3 buildings, out of which 2 are coming in this location, and we have to resettle these PAPs at this location after completion of the structure. This was the vision made by our management and our architects, and we are the engineers. We have to give the shape actually on the site to this vision. So this Kalbadevi station consists of the 2 boxes, K1 and K2. The K1 box is having the footprint on the ground is 700 square meter and K2 is 1800 square meter. And both the boxes provides the vertical circulation path, entry exits, and the third entry exit in Kamaniwadi, which will be connected through the subway to the concourse level from the opposite side of the road. And these 2 boxes are connected with the central cannon of 9.45 meter diameter, and generally in metros the systems rooms are provided in the back of house area, but for this station due to lack or scarcity of the space, we are providing middle of the station. So only if you see that A2 area that is added to, that will be provided to access the mid of house area of the systems rooms required to operate the station. And this is what we promised to deliver to the nation after completion of Kalbadevi station. So how the journey is? So far we have completed 52% of the station. You see the photographs and how the journey is. How we have started and how we have reached 52%, still a small way to go. That's only finishing and some system work. What does it involve? So area at the ground level I told, and this excavation for cut and cover around 50,000 cubic meter, NATAM and concrete reinforcement steel, and deck strut dwellers around 850 metric tons. So this is the view, aerial view. Then why the Kalbadevi requires NATAM? If you see at the first photographs, these are old and dilapidated buildings. Second photographs, where we have generally the structure is bottom up, but for temporary structure we have to go top down because there is no space to stand on the ground. So first we have to create the space to stand on the ground by temporary decking. Then only by small openings we have to excavate the station boxes. You will see the vehicular traffic on the road before start of the barricade. And with this all planning and challenges, we have started with the erection of barricade for Kalba Devi's metro station. And see, this is the geology. Initially 5 meter, up to 5 meter alluvial, after that 2 meter again alluvial brownish to yellowish, then weathered basalt, and 9 meter onwards this is a hard grey basalt rock. This is the conceptual planning, what we have decided how to execute the station. That's excavation of the box, and from after reaching the bottom of the box, we will go for the widening of the platform and central cavern. This is what we have planned. And when we have reached the site to erect the barricade, this is the welcome from the Kalba Devi local public to the metro. So with this, how we have reached to the 50% of the completion. So this is our journey along with the challenges. The first challenge is the acquisition of land, the place to stand there. The second, interest from the local public. This is still going on. Hard rock excavation, logistic issues, extensive seepage, and traffic congestion. So to mitigate the first challenge, acquisition of land, MMRCL has come up with a very good R&R policy, rehabilitation and resettlement. And after knowing the benefits of the R&R policy, now the people from the adjacent building are ready to proactively give their land or properties for MMRC, which is now not required. See, this is the aerial view of demolished building. You see the shape of the box. It is a L shape. Being as an engineer, you cannot erect any gantry structure which cover the entire station. We cannot deploy the crane which cover the entire station. So there are some execution challenges as well. And the road you are seeing, that is always alive. So always hindrance from the local public because in Mumbai nobody is ready to give an inch of land because they don't know what will be benefits they are getting and what will be the end result of that. That's why people are always opposing even for pre-construction building condition survey. So to come out with that, we have pasted the notices like the police on their premises, and again we have given the advertisement in the paper that these are the buildings. We have not given the permission for pre-construction building condition survey. The hard rock excavation is a challenge because we cannot go for open blast in. Yes, sir. Hardly 3 minutes. So we cannot go for open blast because already the station is under litigation in Supreme Court and having psychological issues with the public. The Supreme Court has given a stringent criteria for blast-induced vibration to 2.54 meters due to dilapidated and heritage structures in the vicinity of the station. That's why to avoid that and to avoid the psychological damage to the metro, we have gone for the excavation by mechanical breakers. Extensive seepage is one more challenge because it's near to sea line and initially 6 to 7 meter is alluvial soil, that's why the seepage is here, but grouting has the solution on it, so we have solved it. Traffic congestion, you see the 3.5 meter wide road and which is alive. This is the method what we have used because what we have planned initially to grow from the boxes, but box excavation is got delayed due to mechanical excavation. That's we have started. That's what as a mitigation measure we have changed the entire sequence and we have done the excavation from the tunnel itself.
Wrap up, please.
See, this is the photographs. This is the Nadam excavation. These are the few site photographs which are self-explanatory, and we have the very good regime of instrumentation and monitoring, which helped us to come over the litigations in the Supreme Court. With this, thank you.
Thank you very much. Thank you very much, Mr. Dalvi, for the good presentation. I can think it's really the same level what I have seen, because I was the first man, at least those who are sitting within this. I have witnessed the Chowdi Bazaar because I was deputy chief during that period, and the environment issue, the counseling of the people who are going to be affected, they have tackled very nicely. The RRN, what I can see, the 200 level PAP was there, and it's not easy to demolish the building where the PAP is affected at 211. It's not easy, and of course the most challenging I can handle, since I have also witnessed the same thing, muck disposal. Muck disposal is one of the biggest challenge, because in day you cannot do anything. Most of the materials during night time, that too coming during the night also, so means there are hardly 4 or 5 hours must be having. I think the same thing must be having the same year also. Really is hats off, and they have without any, I can say, problem, they have done it a good job. It is an eye opener for the generation to come to see these sort of things. Thank you very much. Now coming to third presentation, tunneling and excavation in Mumbai urban areas. Again is a case study by D. Fabio, Palash Kachi, Maheshwar Verma, Sandeep Kumar, Sandeep Singh, Sanjay Kumar. Maheshwar Verma.
Good afternoon, everybody. First of all, I want to carry it out to thank the colleagues of L&T for their contribution on this crucial presentation. So, we are in Mumbai. This is an ambitious project that is the MCF, the Mumbai Coastal Road project. We are talking about the package number 4. The contents that we are going to deal is introduction, general introduction of the project, the geology, the TBM, the segment design, the monitoring and settlements, technical buildings, and the retrieval shaft. Okay, the owner is the MCGM. The dev consultant will be the general consultant of all the project, that is ACOM, and the PMC, that is Yoshin and Tech4. The overall length of all is about 10 kilometers and a half, and it comes from Nariman Point to Bangalore. So our load, package number 4, it has a total length of 4 kilometers and a half, surface road of half kilometers, ramps about 1 kilometer, cut and cover about 1 kilometer and 200 meters, and then we have twin bullet tunnels by TBM, Slavi Shield, the largest Slavi Shield never used in India, that is about 2 kilometers. Okay, what we can say is we have an excavation diameter that is very large. It is 12 meters and 19 centimeters with an internal diameters of 11 meters, vertical clearance of 5 meters, and width of lanes that is about 3.2 meters. The number of lanes is 3, and the maximum camber slope is 5%. So, for the cut and cover, we have an height more or less of 6 meters with a width of 10 meters. The vertical clearance is about 5 meters. The other characteristics are about, so the roads remains the same. And then we have the last part of, with a ramp that is covered in order to facilitate the insertion in the territory of Mumbai. So what we can say about the geology, the main part of the excavation is carried out in slightly weathered breccia, and also basalt is present. These two elements will be crucial because in avoiding the propagation of volume loss given by the tensioning of the TBM, to encounter such unit will be something crucial because over there the volumetric deformation within the rock will be blocked. So the only things to deal with is about the upper band that is represented by clay and sands. So let me introduce our baby, if I can say that, our Mavala, with an excavation diameters of 2 meters and 19 centimeters, with an anterior shield of 12 meters and 14 centimeters. Then we have a shield diameters of 12 meters and 12 centimeters. Then we accommodate a shield tail diameters of 12 meters and 10 centimeters. This is for providing a sort of over excavation over there with the TBM curve radius of 350 meters. What we can say about segments that we are going to use, we have been already used universal rings with the internal diameters of 11 meters. The line thickness is 37.5 centimeters. The length of the ring is 2 meters to deal better with the water condition given by the presence very close of the ocean. We have M16 concrete. The segments are connected by bolts and a single rubber gasket is present there. Then we have fire protection through calcium silicate fireboards. When we deal with urban environment, with tunneling in urban areas, settlements becomes the main challenge. So what we can say, we go through a dense population, very important government office, heritage structures, and but what we can say, using the theory, empirical theory, given to the first tube a volume loss of 0.3%, K factor that is going to modeling the shape of the bell of 0.5, we were very good, precise. But this is a combined action, I have to highlight, by designer, execution by colleagues, in this case partners of LNT, and also the control of general consultant at PMC. So it was a combined action of winning factors. So over there we had just 2 millimeters, and in the part of the shaft, as Meshvara is going to tell you, we will have just 15 millimeters. So we deal with the overburden coming from 5 meters at reception shaft until 67 meters under Marble Hill. We had some important issues to overcome, like under the Henjik Ganda reservoir, but over there we had the settlements less than 2 millimeters. Another important topic that we carry out, it was the dealing with the vibration. We used Nishibatsu theory for the upper let's say number of vibration, but we were always under all vibration, and we had less than 1 ppv during the TBM excavation length. Another deal that we are called to face was the presence of water tunnel under our reception shaft, and also for that we carried out 2D FEM analysis in order to assess the structural integrity of the tunnel tube, and we had no problem for that as well, just 0.26 millimeters over there. Now I leave to Meshvara for the rest.
Angelo has explained the typicalities of this entire project. So for this huge road tunnel, we need to house the services of this for the operation of the tunnel without any issues. And also we should be having, like my colleague in the first session has explained about the ventilation Sacado system. So to house all these equipments, we need to have a specific areas where the for an uninterrupted usage of this tunnel. So these two technical buildings are developed in this in the same for this to serve this purpose. We have two technical buildings, one at the south side and another one at the north side of this entire project. So, and also these two technical buildings are completely underground. We want to due to the requirements of the heritage structure, heritage committees and all, we have to put it completely underground. These are the, not only the, it is a simple underground structure, but the challenges which we faced were also with respect to the size, space availability as well. So this is the technical building north at the Priyadarshini Park site. So where you can see the cross section, and it is about 20 to 25 meters of deep excavation was carried out with the help of secant piles, and the entire technical building was housed. So yeah, this is in the longitudinal section. You can also see the Sacado system, how it is being housed and how the pressure is actually being pushed into the curtain cover section. This is the technical building south. It's the Nariman side, and where we know that it's a very space constraint. We cannot go on one side because there is road, and we cannot go on the other side because there is a ocean. So this was a very peculiar challenge for the design as well as for the construction as well, which is right now ongoing. Now let me just take you to the one of the most important and the useful or very interesting topic of this project, the reception shaft. Yeah, by the name suggests it's a reception shaft, but it is exactly not like that. Initially, it was planned to actually retrieve the TBMs from both the drives, but over the over the time, we know what happened. The COVID 2020, yeah, it happened, and there is a delay in the project, and due to that, we had to actually relaunch the TBM from this specific shaft. So this you can see the photograph of the reception shaft. The initial dimensions are like 42 meters width, length of 30 meters, and depth of 26. It's a usual reception shaft with the secant pile supported by the struts and the anchors. But now, when we have to actually relaunch, let us say it as a relaunching shaft now. So we need to actually turn the TBM, lift the gantries, and again after the repair of the gantries, we need to place them again and restart the TBM from this point. This might seem simple on these photographs. I will just want to show you one small photography courtesy to L&T for this video, where we can see that the TBM is being rotated. This is a proprietary tool of Larsen and Toubro, which they have used in this specific project. So it might seem simple with the videos and the slides, but there is a lot in the impact of design as well as the construction. So first of all, from the designer's point of view, we should be checking the clearances and the spatial availabilities, whether the TBM can be rotated.
Wrap up, please.
And also we need to have these gantries have to be lifted in a single piece. We need to have a very robust structure of a modular crane, for which we needed a very sound foundation so that there are no settlements happening. So I will just run through these slides. These are just the checks which we have done to actually help the contractor to understand the issues. And yeah, this is the megalith modular guarantee. We have studied various options on how to actually design the foundation of this structure so that we don't want to disturb the shaft at any cost. So we have studied 3 options, but I will directly jump on to the final option which was suggested and executed, and is the pile foundation which we have done. You can see the rows of piles. A series of 44 piles were done on the either side, and you can see in the middle slide, this is the traveling gantry, and this is in the section the pile. The piles are around 1 meter of diameter at a spacing of 3 meters. Like you might see here, there are also anchors. So we have taken care such that the anchors are not at all disturbed, and the continuous monitoring was done during the driving of the piles as well, so that we are not disturbing anything by any chance. And yeah, so since we have to do design checks, because now we are placing the gantries right behind the shaft, so we have done those definitive checks as well. So this is an example which we would like to present. The construction is still ongoing. You might appreciate if you get a chance to visit this wonderful site. And yeah, I would like to take this opportunity to thank everyone involved in the project.
Lombardi Group, Larsen and Toubro, the general consultants, AECOM, and the Yushin Tech4, and not but not the MCGM, the client of this project. Thank you very much.
And thank you, Mr. D. Fabio and his team. I think they have really doing a good job. It's the first time a road tunnel having dia of 11 meter or 3 lane is happening in India, and this is going to give a great challenge for the new, at least in the NHI, where most of the works in the this hilly area is being done. And most challenging, what he was mentioning about, the first and foremost was the alignment fixing, because a lot of hindrance right and left was there. They are left with only small area within which they had to maneuver their alignment. Otherwise, they have managed it very well. A second was the lowering the tunnel. I had just discussed during the lunch time, Mr. Sandeep Singh from LNT, he was mentioning me that it's the first time they have launched complete TBM. I think it's a weight somewhere 2,000 ton. Okay, this is really challenging for. You can imagine that with the conventional hardly 500 ton. Cranes are used for lowering the cutter heads and other parts of it, but assembled TBM, except for the cutter head, is more than 2,000 ton, and they have especially gone for some modular gantry, I think. And this is also a first time this, since they have got adequate area to assemble and do that part, and even though it's very difficult, I respect everybody. They can visit and see that this is a lifetime one can go and see that. Thank you. We have the next presenter, Mr. Arun Kumar, on the topic conceptual and practical approach of EPB tunneling in soft, hard and mixed shield condition. He is on the line. you, Mr. Arun, to be very precise. And I think it's wonderful done, at least in the near future also, when the geological profile changes abruptly from one medium to other medium. It's very difficult to predict the medium, because from the geotechnical investigation and the limited geophysical, is very difficult to find the changes in the ideal condition. What he was saying, that he has gone with visualized look ahead tunnel program, so that at least he can see that part. And I'm the opinion that nowadays we have to introduce the BIM concept, means you have to retrofitting the advanced probing methods, so that at least you see the real-time monitoring of the hindrance which are going to come, and accordingly we can take the mitigation measure. Because in the past I have seen, due to non-probing of the advances, we are not able to decipher what is hidden things are going to, which has not been discovered due to the geotechnical investigation, and we end up in big problem. Yesterday I was mentioning the case regarding one station TBM where it has struck just below the Gurudwara, and where it was not probed that advanced probing the rock has come. These sort of things, I think this give a great help for the new contracts, so incorporate this beam concept in their contract. Thank you. We have the last presenter of this session, rising from the ruins, arrival of metro at Navi Karim in Delhi, Saurabh Sharma. I am involved in that, I can say it is equally more challenging as compared to Chowdi Bazar station, because if you happen to see that there hardly people can walk during the peak hour, forget about even the rickshaw pulling other things. I think we have some photograph, you can see that part.
Respected Chairman, sir, elders and revered colleagues of tunneling fraternity, a very good day to all. In fact, as sir has just said, I also wanted to comment the same thing, that what is Nabi Karim? Nabi Karim, in the words of Shri Dalveji, is that Nabi Karim is a place where you cannot walk 5 meters straight without being hit by a rickshaw. So actually, this is Nabi Karim. With this, I would like to begin, and that basically this year our theme was underground space, the need of the day. So taking this theme into the mind, I would like to begin with a few issues to ponder upon. Is it only about tunneling or underground space? See, what I mean to say is that if it's only about technical tunneling, we can say, okay, let's go tunnel. It's about design, all technicalities. But I think in urban space, urban area, our reason to tunnel is to get additional space. And I should say that if we are tunneling without proper planning, we are killing at least three times the space over the ground. Sustainable development model leading to net space creation or only underground space creation? Again, the same thing. We have engineers, structure designers, machine manufacturers, project managers, contract managers, waterproofing experts, and even IT experts in this conference. But unfortunately, I could not see any architects and the planners here, whereas the theme is underground space. So it's high time to think underground spaces as an integrated sustainable model, or else they shall soon start becoming a mancannial to the at-ground infrastructure. So for us, mancannial means a tree which does not allow any other tree to grow adjacent to it. So with this theme, I want to begin our discussion, and this is a short journey to probably one of the few initial efforts towards sustainable underground space development in the country, and its integration with its overground counterparts. The presentation in this case study deals with planning and designing of underground interchange metro station at Nabi Karim, which was proposed to cater Janakpuri West RK Ashram corridor and in the low campus corridor of phase 4. Then challenges faced during land acquisition for the same, integration of this project with another project of the land owning agency. Then design challenges felt during this, and challenges I shall discuss because I have to rush. So basically this is the map. You can see the Nabi Karim metro station. Both the lines are future lines, phase 4 lines. One is sanctioned, another one is not sanctioned yet. This was one of our challenges. So we were creating an integrated station, one below the other, both platforms one below the other, and that station would cater for both the lines, one sanctioned, one not sanctioned. This was one of the challenges, how to basically integrate these things. Then something about Nabi Karim. Nabi Karim is I think at most 3 to 4 kilometers from the Connaught Place, the poshest area of Delhi. But unfortunately, what is Nabi Karim? The road widths are extremely narrow, encroachment on either side of road majorly due to vehicle parking, presence of heavy vehicular traffic due to loading and unloading of material which is frequent throughout the day and night. Then acute congestion situation due to practice of transferring the unloaded material manually or through man carts. This is Nabi Karim, sir. So what was our planning? Our planning was to decongest this area, to make this area come somewhere nearby Connaught Place, which is actually very near to Connaught Place, but it's very far away from the Connaught Place. So we wanted to give it a metro connectivity, and in fact we thought of giving it not only single connectivity, a double connectivity. We thought we went for 2 corridors at the same place. Then we went a step ahead and thought, okay, we will have an integrated station. Then the problem came how to integrate the station, because there was no land at all. I can make a single line on the road, means by some method or other. But when there are 2 corridors running in some angle, the road is not wide enough to accommodate that angle. You will just see. So this was a land identified by us, which was 26,000 square meter of land, which was belonging to government agency, which is Municipal Corporation of Delhi. Unfortunately, this was the only land that was available there. In fact, this was the only land piece, and this was the government land piece, and this was available because this had been a slaughterhouse for a long time, and then it was a parking. So we needed it because we could not make this much of a station box area onto road. This is a drone image. You can see, except that land, everywhere there are houses and houses and houses. So this was the only land piece available in almost 3 kilometers area or so. We basically, okay, so what happened was that we sent a request to MCD asking them to give us the land or at the government exchange land rates. But after we continued the design because DMRC does not stop such design. But after 1 year of pursuing the same, in 2019 March, MCD convinced that they will not be able to give us the land because they are already planning some of their revenue generating model, which would give them 550 crores upfront, 13 crore rupees per annum, then around 2400 ECS per car parking. When we stressed that this is essential for us, they told us, okay, you go with the same policy, give us 550 crores, 13 crores per annum, 2400 car parking, and take the space and do whatever you want, which was not possible for us because as per the government exchange rates, the cost for us, what we could do was at most 35 crores. Then the MRC also understood that the project which MCD was doing was essential for their revenue as well as the area, because they were creating a car parking, a multi-level car parking which was required for that area, and as well as a commercial space which would actually uplift that area
to the extent which DMRC was visioning. So eventually DMRC management and everybody and the whole team sat over the boards, and we came with the integrated solution. Sir was involved, and I would acknowledge the efforts of sir and everybody from our higher management. Finally, we came with the solution. We said, okay, you are initially the MCD was having 2 floors of underground space and then rest elevated. We said, okay, you just sacrifice your 2 floors of underground space, give us metro station. We will make 4 or 5 story metro station underground. You go over the ground. What we will do for you? You will not need foundations. We will be your foundation. So this was basically a good for all situation, win-win situation for everybody. So I am being very crisp.
Wrap up, please.
So finally, this happened. This was a G+8 story building over the ground with the G+2 commercial and 6-story multi-level car parking, which is fully automated. There were other issues like as there were scattered timelines. So we ensured that okay, we will do complete the foundation up to the ground level, and once the concessioner for MCD comes, they can begin from there and make their building. Then the huge numbers of columns that were coming into our station, our DDC did a great work by camouflaging all those columns, by integrating them with the D-walls and by camouflaging them in the other systems, so that nothing influenced our fire service, nothing violated the fire norms or any other norms. Then there were contractual provisions that in case Nilo campus corridor is not basically approved or delayed, then what we will do? So what we have done is that we have asked this our current contractor, station contractor, to build the structure of whole station. In case we have to ask him to leave somewhere, we will say okay, leave here, and we have a clause to deduct that amount from the contract at the rate for which he has quoted that in the DSR, the Delhi Schedule of Rate schedule. So we will not have any disputes in that regard. This is the cross section. You can see 2 platforms, one below the other, and the structure above. This is a ground level plan. Then a concourse level plan for the underground integrated station. Upper platform level plan. This is Janakpuri RK Ashram level plan. Interchange level plan. This was required to interchange since both the lines were at a skew angle of 60 degrees. Then lower level plan, the lower platform for the Indrelok campus corridor. And this is the L section. Our MD asserted that we have to try at all costs to ensure that public is not inconvenienced. Okay, sir, I'll just wrap up 1 minute. Is not inconvenienced, and the access is directly from the concourse also the lower platform, and from each platform to each other also. So we ensure this by having an additional interchange level. So this is my message, that imagine before engineer. We all are designing, but at least we should imagine also. Sir, I would take this leverage that meanwhile I am having the questions, or since it's the last session, we can continue with the video. My presentation is over.
No. Okay, sir, time is over. We have to start next session. Thank you, Mr. Saurabh Sharma, for this nice presentation. I think need of the day nowadays is the non-availability of land. You can imagine urban area very difficult to get the land in this area. Now the option left is you have to make an integrated approach. You cannot work in isolation, different silos, so that one can get the land. Here slightly we have gone out of box thinking, and that we will make an interchange station and help them to engage the concessionaire as per the requirement of upfront 550 crore which they have envisaged, so that is a win-win situation for everybody. Thank you very much. With this session 5 is completed.
Thank you, Daljit sir. with this, ladies and gentlemen, we come to the end of technical session 5 on urban tunneling. May I now request sir to kindly present a memento to all our speakers. So may I request all our presenters to kindly line up here so that we can go ahead with the memento presentation ceremony. May we have Mr. Sashank Surve. Then can we also have the speaker from MMRCL, followed by Di Fabio Angelo and Maheshwara Verma and Mr. Saurav Sharma. Can we please have everyone on stage? Can we please have a warm round of applause for each one of them? Ladies and gentlemen, with that we come to the end of technical session 5. I thank Mr. Singh for conducting the session as the chair, and we shall now break for tea for 15 minutes. In the meanwhile, I request all the presenters for the last session, if you haven't yet uploaded your files here, please have them uploaded on the system. And our next session, our last session for the day, would be on innovative techniques. So I request each of the presenters, if at all you haven't had your files updated with us here, please have them uploaded before your presentation begins. Thank you, and we shall join back in the next 15 minutes.
Hello. Hello. Are we audible, sir? Your attention, please. All delegates are requested to take their respective seats.
Ladies and gentlemen, with this we now come to our last session of the day. May I request our chair, Mr. Andrea Panseria, to kindly proceed towards the stage so that we can start with all the speakers for innovative techniques. Ladies and gentlemen, at the end, can we please have all of you take your respective seats so that the chair can start with the session. May I request all the delegates that are standing next to the stalls, can we please proceed towards the respective seats so that we can start with the session. Our chair is already here, so
Ladies and gentlemen, I know it's hard. Be patient for the last 1 hour. Is somebody else arriving? Yes. I think we should have a microphone also in the antechamber. A speaker at least.
Can we please, can I request the third speaker from MMRCL to, can I just have him here next to the stage please, once? The third speaker from MMRCL.
Mr. Vikas. Yeah, he'll be presenting with
ladies and gentlemen, delegates, we are at the last session. Be patient. Maybe the delegates will be lucky to have half a minute more each, but no more, because everybody is willing to leave, unfortunately. Let's try to keep the people awake. We are here in the technical session with about innovative and, for what I saw from the title, some rather particular techniques, going from the TBM retrieval transportation to blast-resistant design. So very interesting things, as the last one about the power supply for tunneling mountain. We don't have to forget that tunnels, once they are excavated, they have also to serve for some purposes, and railway tunnel nowadays, they need power, and this is a particular challenge. Now let's start with the keynote presentation: retrieval, transportation and lowering of tunnel boring machine by strand jack gantry system without dismantling into components. From Mr. Dange, Tilak, Kolge and Belal of MMRC, and to present is Mr. Rohit Tilak, correctly. Rohit Tilak.
Okay. Hi, good evening everyone. I'm back again.
Like
My
for
name
everybody
is
before,
Rohit
10 minutes.
I am Senior Assistant General Manager for MMRC. And today I am going to present on retrieval, transportation and lowering of tunnel boring machine by strand jack gantry system without dismantling into different components. But I see people outside yawning and trying to leave. But don't worry, I will not bombard your brains with alpha beta equations or lot of sketches, lot of flag 2D, flag 3D, flag Cs or phase 2. Or maybe I will not try to sell my ultimate 1000 years product to you. So basically, the name sounds very complicated, but trust me, it's very simple for you guys. And basically this was a concept, and that concept got into sketches, and that sketch was into design, and that design was proof checked for stability and everything. And we then converted this everything into a practical approach. So mostly you will see photographs, and then you have a desert as a video in the end. So for details, for design details, for cost calculations, for construction methodology, you can always contact MMRC office. So this will, I'll make it very sweet and short. Okay, thank you. So I think everyone knows 33.5. I think a lot of speakers have told you about the line 3, 26 underground, 21 is at grade, connects a lot of CBDs around. So basically, this is regarding TBM1 and TBM2 in package 3. So TBM1 is Stanza 1 and TBM2 is Stanza 2. And package 3 is, the tunneling is around 4 kilometers approximately. It starts from Mumbai Central to Worli, and at Science Museum we have a shaft. So it's in the middle basically. So I think it's all standard 6.65, 5.8, 6.35 outer diameter. So the conventional method of retrieval, transportation and relaunching of tunnel boring machine involves separating TBMs into different components and transporting them individually to the shaft location. And after undergoing maintenance, they are again welded together. But this process is quite painstaking, costly affair. A lot of time is wasted in this. And basically, the package 3, it's into old cities, so we cannot, take this kind of pain. And Mumbai Metro 3 is basically, it's a project of urgency. So we had to look a solution outside box. So TBM Stanza 1 and Stanza 2, they started the main drive from north side of Science Museum station towards Worli. So both TBM approximately covered around 2 kilometers of tunneling, and there was the breakthrough. First it was TBM1 and then it was TBM2, and we got delayed for almost 4 months because of the geological conditions, because we had predicted around good grade 2, grade 3, but we got a lot of clay patches, so there was a bit delay in the breakthrough. So after the breakthrough, the TBM were pushed onto cradles, and then connection of rear gantries were discontinued. Further, this TBM were pushed by roller and push jack system to get it into retrieval position. So Tansa 1 and Tansa 2 were retrieved from the bottom of the shaft entirely without dismantling using jack gantry system. So mostly jack gantry is like a bigger form of pulley. You have a small pulley, this is like bigger pulley in a simple sense. So prior to transportation of TBM, we had a mock one day before the day, and to observe any kinks in the actual transportation or any critical issues, and so we could troubleshoot them the same day. So Tansa 1 and Tansa 2 with cutter head having length 12.5 meter, diameter around 6.65 meter and weighing around 500 meter were transported from Science Museum, from Worli to Science Museum using self-propelled modular transporter vehicle. Basically this is a 24 axle of vehicle, and this can take around 600 metric tons of capacity of any weight. So basically this was used first time ever in India. So TBM passed through a lot of narrow lanes. The Worli, there are a lot of chawls, a lot of slums, a lot of old buildings. So this passed through a lot of narrow lanes of Worli. And I remember that was like the March, so where people were studying for 10th, 12th. So all the kids were awake, and when the kids are awake, even the parents are awake. So, and we could see people were like really whistling, shouting, dancing, when it looked like a machine from outer space, like from Star Trek. It has appeared in the earth, and people were like dancing. There was a lot of music, so we feel very motivated. तो लोग जनरली गाली रखते हैं कि मेट्रो ने ट्रैफिक जैम कर दिया, गड्ढा कर दिया. So it was very inspiring for us. And I also remember there was like small 8-year-old kid. He told to his mom, like he told in Marathi, हा लालबागचा राजापेक्षा मोठा वाटतोय. In Hindi I will translate, this TBM is even bigger than the Lalbagh Raja. Basically it's a Ganesha. So that's how we got inspired, and it really moved us. So normally the government agencies like BEST, MCGM and Mumbai Traffic Police, they normally don't support, don't coordinate, but this was something special for everyone. So they helped us in removing a lot of cables, lot of traffic signals, even the parked vehicles on the road and light poles. So afterwards, TBM repair works were carried out at north side of the Science Museum, and in parallelly, the jack gantry system was shifted from Worli to south side of Science Museum. So further, the TBMs were undergone maintenance on the north side, and they were again shifted to the south of the Science Museum using a self-propelled modular transporter. So again, this TBM shield lowering was performed, carried out using the jack gantry system. So it was horizontally pushed downward, and then it was using roller, it was pushed inward, and again the gantries were again locked inside, and the TBMs started working on this. So we can watch the live video. So this method resulted in saving almost 25% of cost and 60% of total time taken as compared to the conventional method. Thank you.
Thank you for the very quick presentation and for the interesting operation. It has been a challenge, really, I think, to move such a machine in such narrow conditions. We know that. And now I want to call for the second presentation about ventilation system in large hydro project in India, a case study of successful implementation of effective ventilation system at the Tehri pump storage project, written by Mr. Kumar Khali and Sadik Popnis from Infra Project 1 and for Meet Board Peace University Pune as a professor. Mr. Rakesh Kumar Khali to present.
Yes. Good evening to all. I am again here. So I am talking about ventilation system at Tehri pump storage project again, because it's a very compact project, and ventilation system in such a complex project where edit length, several edits are there, and edit length is, aggregating length is more than 20 kilometers. So for that complex structure, ventilation system where more than 400 to 500 people are working. So ventilation is the lifeline for the workers and engineers working there. So we adopted a ventilation system after going through so many innovations, and because it is attached to hydropower project nearby, which is operational. Earlier excavated tunnels also used for the ventilation. So I will be discussing and this how we have adopted the system and what type of ventilation system we used in this. This paper is authored by myself and Professor Sandeep Potnis of MIT WPU. So I am going ahead with the presentation now. Construction of large tunnels and associated large caverns excavation require an effective ventilation system along with the other construction activities, with the sole objective of timely completion of construction with due regards to safety and overall economy. Ventilation system is required during the construction of any tunnel or any underground excavation, whether the same is constructed by blasting, boring, or placing prefabricated tube in trench. Blasting, boring and several other activities while working on tunnels and underground caverns are followed by production of dust mist, fumes and toxic flammable gases. These contaminants must and can only be removed by ventilation, which provide a suitable, safe working environment for the construction workers. At Tehri, most modern construction equipment have been selected to enable faster excavation. The objective, therefore, is to arrive at the appropriate size of ducts and kW rating of fans specific to the layout of the proposed system of ventilation. The type of optional diameter of ducts we have considered, the layout of the duct line, the number of position of fans, the dynamics of the performance of fan, the power cut and the arrangement for that, the quality and strength and parameter of duct. So this is the tool. You can see here we are constructing this surge shaft, 140 meter deep. This also requires ventilation. This is connected with one adit here, and then again from the bottom also for butterfly wall chamber, which morning we discussed, and then penstock assembly chamber, and again 4 140 meter deep vertical pressure shafts are there. Then from this adit 9 here, this is the main access tunnel, and then connecting tunnels are also there. Just see the complex structure. So ventilation is really a big task. It's another project for us before going ahead with the excavation. The structure involves upstream surset 3, upstream surset 4, butterfly wall chamber, penstock assembly chamber, drainage gallery, vertical penstock, ventilation tunnel, draft tube, machine hall, bus bar, TRT 3 and 4, downstream surset 3, downstream surset 4 and TRT outfall. So this is the complete project. Within 1 kilometer you will, 1 or 2 kilometer you will find the entire project. And then it is connected to the earlier commissioned project. So things are very complex, and because running project is there, then we have to see that machines are working. We have to see the safety of those working machines, as well as whatever new machines we were bringing, that also need to be taken care. Presently, 3 major construction ventilation systems are typically applied depending on the site requirement. Force ventilation is the main ventilation people are using now, employing flexible ducts to introduce the fresh air, and directly to the work sites, exhaust fans, exhaust ventilation system. In between, we are providing somewhere if fumes are generating, because lot of welding is taking place inside, in powerhouse, machine hall, everywhere. So that need to be taken care. Already a ventilation system is proposed in this ventilation tunnel. That also, till the time that was not open, daylighting was not done, there was a problem. Then exhaust system also we utilized. Circulation ventilation system mainly used in double bed projects where fresh air is introduced, one bore and consumed air is extracted via cycle. You just see which this is the 3 fans we have provided at it 9, that main access tunnel. So this picture shows these ventilation ducts. It is going inside. Then again, it's like a bhool bhulaiya here. Then you have to go one side, then second side, then upper bus bar, and all other structures are connecting after this 1 kilometer area. So these 3 ducts were provided initially, and another route also taken, and there are fan system that also I will explain in this. These are the location where we provided Edit 3 portal, excavation of powerhouse cavern for bus bar shaft and bus bar. Then Edit 9 portal also we have provided excavation of drainage gallery, powerhouse, access edit to service bay, access edit to pressure shaft bottom, and Edit A7. Then main edit, that is Edit 9 portal, edit via access route, which you are seeing here. In the earlier picture you have seen, that is Edit 9 portal. Edit via access route to the top downstream surset. Then again Edit 9 portal, edit to bottom downstream surset, intermediate edit to TRT, TRT3, TRT4. Then Edit 1, that is surset top edit, the first one. Butterfly wall chamber, then penstock assembly chamber, PAC, and HRT. For this separate ventilation system is used. Edit AA1, edit to upstream surset, portal tunnel, and ventilation to PSP.
2 minutes.
So maximum number of person, because nobody goes in detail what type of ventilation system is required, how many people will be there. Because in India, the manpower is not very costly. So you will find so many people, more than 20 people. So you have to give this, you have to take how many engines are working inside, how many this contamination will be there, that also to be taken care. So we worked out for this 20 people we have taken. Then requirement of fresh air in cubic meter per second per person is 0.05. Total requirement of fresh air for 20% is 1 cubic meter per second. Then if we consider wheel loader is working for mucking, one number, that is 8.6, 0.1 cubic meter per second per BHP we have to consider. And same way if dumper is there, so total 17.24 cubic meter per second fresh air is required at phase if we are going to design a fan and ventilation system. So this is the first activity before starting the excavation. Otherwise you will land in such a great trouble and you will associated diseases are there. And we have seen in the earlier project when ventilation systems were not available in India. In Nagaland project, that was my first project in 1994, several problems we have faced, and most of our people after completing that project, they were not in a position to work independently, always under medicine. So simple design calculation is also there. So total air pumped to the portal at the end is 9 cubic meter per second. I am not going in detail because all these calculations, this presentation will be available for you, and it is given only 10 minutes, so I will skip this. And then pressure drop calculation is also there, and then 75% capacity the fan will run. We have used G-tron fans for this. We have used ABB fans. Somehow they could not perform, then we have adopted G-tron fans. They perfectly work and we could complete the entire excavation, and last month we could complete everything very successfully and our people are very safe. This excavation of powerhouse cavern and cavern to busbar shaft, this all details are available. I am not going in detail, and this is the system we have adopted. And the independent ventilation system is, it was not connected to any other structure. It is for the bus bar, upper bus bar and lower bus bar, control block, and for machine hall. So this is the system and calculation we are giving. So this is the different type of paper we have prepared so that everybody, a newcomer, also understand. Ventilation design for different structures. This airflow calculation for fan stations were given. Ventilation for different structures, again for excavation drainage gallery around powerhouse, access added to service bay and access added to pressure shaft. This we have calculated for this also how much capacity fans are required. That also we have calculated. It's very easy calculation we have done. Because it is nowhere available. We have discussed in detail with the ventilation agency and then worked out. This is the annexure for this. The same way edit access route to top of the downstream shaft, because it was 70 meter deep, so ventilation was required. It was connected with the edit 9 portal, that is the main access tunnel for the project. That also we have calculated here. Ventilation design for different structure, again this in annexure how we have done it. This is the extension to the edit 9 portal. Edit for bottom downstream shaft intermediate edit to TRT and TRT3, TRT4.
Sorry sir, do you have another slide or two?
Yeah, I'm going
to close.
So all these calculations you can go through in my paper because it is very well elaborated and you will understand. If anything is there, you can call me directly. I'll share my number. I have given my email ID also. And this is also for the another structure, because connecting structure we have huge. I told you the aggregating length is more than 20 kilometers. So all these we have worked out, and a safer ventilation system this way we have designed. So now comes to repair, care and maintenance of flexural ducting. So cold repairing kits we have used, then hot repair kits also we have used, then audit of tunneling duct ventilation system is required. One gang was separately arranged for this so that they can check every day and then take corrective action for that, so that there should not be any leakage in this. Then same way or other precautions also elaborated here.
I'm really sorry, but we have to move
now
because there are other three presenters.
Okay, now it is almost, our excavation is complete very successfully, and I was involved with this project for last 6 years, and not a single incident, single fatality took place. And our people, we have taken care of the safety of the people, and this way we have given a effective ventilation system for the project. Thank you very much.
Thank you. I'm sorry for the time, really, and I cannot stress out in any case how important is this topic, because it's not only excavation and support a tunnel, but people have to live inside the tunnel and have to be safe, and air is the most important part to have. So it's very detailed study and very important and very essential also for other projects. I don't stress out sufficiently when you submit or think or to submit, or at least you study a project, to also consider ventilation, because it's very important. We live with air and we need it. And in such complex powerhouses and ducts, it's not so easy to understand how the air is functioning. So very thank you for the detailed study. Now we have to move very, very quick to the next presentation about evolving technological advance in shotcrete for ground control support in tunneling, underground construction and mining by Normet engineers. I think is Mr. Tripathi to present with Mr. also Oikonen as
Mr. Panu will be co-presenting with us remotely.
Thank you. Oh, thank you so much. So please remember, I'm stressing again, 10 minutes. I should say that it should be between 10 and 12 slides usually.
Thank you, and that is our objective as well. So very good evening, ladies and gentlemen, revered chairperson and very distinguished and august gathering over here. My name is Dhyanendra Tripathi. I will quickly introduce myself. I am a mining engineer, graduated from the School of Mines and having 24 years of industry experience, mainly into the underground construction and mining. Presently, I am rendering my services as General Manager Project Operations at Normet, and we are going to present to you today the evolving technological advances in sprayed concrete. So sprayed concrete, it looks like it's only a part of tunneling, but how immensely it has contributed, that we are going to see into the upcoming slides. Safety is paramount for Normet, and we always try to be safer every day. So tunnels, while we are discussing the need of the day, underground space, so tunneling has helped people at ease to flow at all the times, and it has helped immensely for the efficient flow of resources and people via utilizing underground space. So tunneling is ever evolving. It has been a long time when tunnels were excavated manually, and now they have come to a juncture where we have embarked to the most advanced tunneling technologies. So sprayed concrete being the integral part of DBM, and at some cases for the where the continuous miners are also used, we use sprayed concrete, and even in tunnel boring machines at a few of the places we essentially use sprayed concrete. This slide was it was common to one of the presentations earlier, but again I would like to emphasize that what exactly changed from the early days when we were doing the temporary shotcrete lining first, and then we were giving the geotextiles or sheet membrane for inhibiting the water ingress, and then using the permanent cast-in-place concrete. And now we have come a way forward wherein we are using only shotcrete lining for both the temporary and permanent lines, while using, sometimes it's very much optional that whether we are going to use the optional sprayed applied membrane or not. That's very much on the jurisdiction of the engineer in charge whether he uses or not. So design change drivers that has been witnessed, the permanent sprayed concrete, the automated mechanized construction that we are going to touch into the upcoming slides, sprayed waterproof membrane, surveying technology, improved structure fibers that has been discussed in length in early presentations, highly skilled operators, improved design techniques, architectural solutions, and courage for innovation and trying new things that our engineers are doing. So these are, few of the lining designing and performance requirements. While, we are looking at every day, passing day by day, we are looking at the serviceability conditions that we need to service our tunnels for more than 120 years or so. It was not earlier such. Though there are monuments, those who are intact for several thousands of years, but while we are constructing the underground spaces, those who are vulnerable for number of hostile environments. So there, having a design life or serviceability of 120 years would be something that needs a lot of rigor in terms of construction. So you are seeing into the picture. The first is primary shotcrete line, then regulating layers, then a sprayed waterproofing membrane, secondary shotcrete line, and then tolerances, and then obviously the cladding system for the either architectural purposes or for providing the smooth ventilation, etc. These are the tunnel designed with permanent shotcrete line. This shows that how we have evolved so much that that there is a huge tangible and intangible benefits. In terms of saving, if you see the carbon footprints, we can reduce 23%, whereas the savings in concrete can be more than 36%. Obviously, this is no brainer to a civil engineer or a tunnel engineer to have a perfect kind of ingredients while designing the right kind of and perfect rheology of shotcrete mix. So the grading envelopes, they vary globally, but obviously they do have one thing is common, that they should suit the needs where we are going to spread the concrete, the particle packing, the matrix probability, pumpability, and cohesion, etc. It is always debated that which kind of material we should use, so locally available ingredients are best suited. We'll have to be a little bit mindful that what kind of sand we are using just for the environmental purposes. Nowadays, engineers have come up with the M sand, the manufactured sand, and a lot of other possible options. So with this, I would like to invite my co-presenter, Mr. Panu, who is the Director Underground Solutions Process in NOMET, to present the results slide. Panu, are you there? Great. Could you please a little bit volume, please? Yeah, you are audible.
sir. I'm obliged to call you to summarize as much as possible.
Okay. Thanks,
Thank
Manu,
you so much.
for your valued information and the way you have presented. Thank you for sharing the knowledge today. And this is the last slide of the presentation. So we have embarked to a new journey wherein the NOMET has developed expertise called sprayed concrete process, where we deliver the entire value proposition to benefit our customers and our partners at large. So this starts with the production of concrete until the spraying of concrete under one umbrella, and you can rely on us because we have gained and gathered a lot of experience and expertise into the sprayed concrete process, and we are ensuring that this is going to be aligned with the sustainable world, and in Indian subcontinent we should take the same stride as we are taking globally. So thank you so much, ladies and gentlemen, for listening patiently to us, and we look forward to serving you at all the times. Thank you so much.
Thank you so much for your technological contribution. I have to say that in the last years of my experience, I see a very large increase in those technologies. It is a good one. I have to say that the scanner for the layer thickness diminution is something I would say wow, because it's always a problem to define a sufficient and reliable situation regarding the shotcrete thickness. I have again to tell that regarding the spray membrane, like I was also telling during the workshop, I am very interested in those technologies. They are interesting, but please take care that for deep tunnel, when it's required to drain spray membrane that is sticky to the shotcrete, has some problem to let pass the water where we like, and then that would induce loads on the lining. That has to be known. So this is a technological choice, not impossible, but to be known to the designer in order to design accordingly so far as possible. Not always all technologies can be applied. Thank you so much. Now we pass to the one before last presentation. Unfortunately, two speakers were not able to present, but design and construction of NATEM Sahar crossover using fiber reinforced sprayed concrete secondary lining of Mumbai Metro. Present will be Ashwaradendesh Pandey. I call the speaker. Thank you. From MMRCL to present this project. Thank you so much. Again, 10 minutes plus a bit, please. Okay. 10 minutes plus a bit. Thank you so much.
Good evening, everyone. I have a task of presenting the design and construction of NATEM crossover, which is done, the final lining is done in sprayed concrete lining for Mumbai Metro Line 3. And I feel that this is one of the very new technology adoption which we have done in MML3. So this is a brief about what Mumbai Metro is. It has got 26 stations, 33.5 kilometers long, and 5 NATEM crossovers, in which we have adopted FRSCL concrete lining, final lining in Sahar Road crossover. Primarily, the adoption of FRSCL was done to see that how can we reduce the stand-up time, to eliminate the use of formwork, and see how we can reduce the use of reinforcement, because use of reinforcement is predominantly directly proportional to the durability. As soon as we reduce the steel fibers, the durability of the concrete used increases tremendously. The second thing which we wanted to do was to use fully bonded waterproofing, and it helped us with the sprayed concrete waterproofing. So this is predominantly the geometry of the NATM. There are people who would say when you are using sprayed concrete lining, why there are head walls, but this design got developed from a basic concept of conventional construction by cast in place concrete, then to sprayed concrete lining. Dr. Florin Kren also is here, so he knows. CPM sirs are also here from MMRC, so they all know how this thing got developed. But this is a very good concept where we have saved lot of labor and time in construction. However, the portion to deal with the head walls, we had faced some issues, but the innovation in this is that we have understood the nitty-gritties of how FRSCL will help us in doing NATM final lining. So the geometry is, they are nomenclated in certain ways and their dimensions are given, and the thicknesses which we used for different widths and depths and for different lengths. The design principle, we have looked at the design principle with two approaches. One is to look at the MN curve, that is the moment and axial force which is induced due to all sorts of force coming onto the NATM with this curve which is shown, and the other one is to go to the first principle and check the principal stresses in the concrete lining, where we have ensured, when we look at this system, we have ensured that the stresses, the principal stresses do not go in tension beyond 2 newtons in all cases, and the compressive stresses remain within sigma CBC, and obviously the shear stresses remain within limits. This was done with sensitivity analysis, different values of lateral pressure at rest and different values of spring constants, and looked at the cases where on the higher side the K0 was taken as 2 and the sensitivity analysis was done. Design loads are usual, everyone will know: long-term loading, short-term loading, accidental loading, all this, and this is what I have written, what I have explained, that the K0 was taken, how it was taken. Hydrostatic pressure was taken with water level at ground level, and for accidental level where water levels were at high flood level. The analysis of the FEM was done in RS2, Plaxis and STAT, compared the stresses induced on the lining. Codes and specifications used are BACN 14487 and 14488, which talks of how the sampling needs to be done for the fresh and cured NATM sprayed concrete done on the in situ areas, and samples were taken, tested for all testing for flexure and compression. And the second approach which we used was the first principle of reducing the principal stresses and the minor and the major axis and the maximum shear stress. The same principle here, we have kept the tensile stresses within limits to 2 newtons, and in all the cases the thicknesses were derived in such a way that the stresses are not in tension. We have checked that and then arrived at the thicknesses. The construction sequence predominantly is primary lining, which is normal, rock bolting, shotcreting, etc. After that is done, we do installation of drain regulating layer over the primary lining and apply waterproofing bonded distance sprayed waterproofing. Then we have spraying of FRSC in a secondary lining. As explained in the previous discussion, the quality control to ensure the thicknesses of the primary lining and all that were also done, majorly using the unconventional first principle methods of checking the thicknesses the layman's way by using the scales and all that. But that was a good insight in the previous talk, that we can now use computerized what is it called, monitoring of the thicknesses, and ensure that we deliver the deliver the thicknesses as per the design. Then this is the principal section of how the primary lining, the drain regulating layer, the sprayed concrete member, then the secondary lining and the fireproofing. We in this discussion do not talk of fireproofing because this is beyond the scope of this paper. The advantages, as we discussed in the first page, I'll come back to that, is that FRSCL reduces the stand-up time, eliminates the cumbersome foam work, which we generally do, eliminates the reinforcement and therefore enhances the durability, and obviously ease of providing the waterproofing and ease of laying the concrete, because we are doing sprayed concrete. However, with our
1
experience,
minute, sir. 1 minute. 1 minute, okay?
1 minute more. Yeah. I am on time. Yeah. So, the first and foremost disadvantage while working on it, I found that there are very few standards pertaining to design of FRSCL in NATM. Per se, what we have used is codes and references which are given in Eurocode, and some of the references from the US Army Foundation Manual, NATM Manual and all that. So predominantly the design which we have adopted came from research-based papers. That meets this forum is the best forum to come together and formulate a standard on this, I think, so that this becomes a very a fashion of making the concrete final lining, because it reduces a lot of labor, a lot of pain to construct the temporary foam work of different shapes and different sizes, and saves a lot of time. And frequent use of this in NATM final lining would definitely bring the cost down, even with all this efforts of using sprayed concrete lining. The cost definitely is lesser than the conventional cast in place NATM final lining. However, the disadvantage is that we require to do a lot of tight quality control. The personnel who actually do the spraying of concrete and all that needs to be trained. It's not as easy as to be done by a layman, which generally a cast in place concrete with formwork can be done. Though in NATM there also we require specialized personnel to do it, but this requires skilled labors. The most important part which we have seen is that in Bombay, where it's a coastal area, groundwater levels are high, keeping the surface, excavated surface and the primary lining surface dry before the final lining is sprayed is a task in itself. It requires a lot of grouting, ensuring that no water comes in and all that. So that is one task which is something wherein we have to put in a lot of efforts to come to that. So I've written that in the disadvantage part. The groundwater over a period of time may expose the steel fibers, but this is something which is accompanied with the steel fiber use in concrete in any case. Use of steel fibers, then we have to ensure that the workability of concrete, which is because of the lumping of the fibers and vis-a-vis use of spraying and bonding and the gain strength is something which needs to be looked into in detail, and some more study needs to be done on that. And the foremost as a designer which worries me is that the uniform distribution of fibers is a concern. So we need to work on that. So that's also a disadvantage on this. So these are some of the pictures of the project where we have done final lining. So if you see the first photograph is about the NCF1 where the actual crossover happens on the track. So you can see the tunnel eyes here in the first photograph. Then the second photograph is how the regulating layer and drainage mat is laid. Then how is the FRSCL third photograph is sprayed. And this is one of the final tunnel lining. Thank you very much. I think I've done it in time.
Thank you so much for your engagement. Also here there is many things, there are many things important to see. I appreciate the force of the client to go into this kind of lining because it's not often. There are actual durability aspects, there are actual quality aspects, there are also structural aspects for us, more design engineer, a layered structure that is not monolithic, so also the bond between the various layers has to be assured, in my opinion, has to be tested in order to assure that the bond and so the cooperation of the various layers is actual, and also, if ever, to consider attentively the cooperation of the what is called primary lining or supermeasure, where usually the quality, because of other urgencies, stability, is not such to allow this to be part of the final lining. All of these concur to have a new tendency in design to apply new material, so I applaud this client that has this idea in this case for a very complex working underground. Thank you so much. I would like now to call the last speakers for if I'm not wrong, I can have a confirmation. Two speakers, unfortunately, they cannot participate. Is correct? From the table. Sorry, ladies. Is correct. Two speakers, they are not here with us. So we go for the last one. Correct. So I call from Lombardi, Mohamed Iqbal, Smith Verma, Mahendra Rana, to talk about reliable and redundant power supply scheme for mountain rail tunnel. This is the last presentation. Please smile, because in 2 minutes, no, maybe a little bit more, we will be finished, but it's very interesting because it's not only tunnel. Tunneling is not only tunnel, it's also, in this case, to supply power so that the train can pass in it reliably, constantly empowered during the whole life of the project. Thank you.
Yeah, thank you. Good afternoon to all. My name is Mahendra Singh. I am actually in Lombardi. So here I am going to explain about the electrical power distribution systems for especially for rail tunnels. As you know, the electricity is very important in our life. So we cannot imagine our life without electricity, especially in the rail tunnel projects, which is in at remote location, and maintenance is not easy job. And inside the tunnel, we have a lot of critical systems like lighting, emergency lightings, and the control systems, SCADA, the gas separation systems, and especially for tunnel ventilation. So these all critical system needs a reliable power supply. In case of any power supply fails, the system will not work. So just I selected one of our projects. This is a rail tunnel project. Our client is ISCON, and Lombardi has done a complete detailed design for E&M systems, including the tunnel ventilation and the civil work. So the status of this project is design work is completed, civil work is also completed at site. Now E&M construction, means commissioning and installation work is going on. So this is actually selected one tunnel. This is T49, and you can see here the tunnel length is approximately 13 kilometers, and it is a twin tube tunnel and single track, and both escape tunnel and main tunnel connecting to cross passes at every 375 meters, and these cross passes will be used for the fire escape route in case of any emergency inside the tunnel. So you can see here at both portals end of the tunnels we have provided our electrical substations, and which is combined 33 kV and 11 kV substation, and inside the tunnel also we have provided 4 numbers underground substations towards the escape tunnel. So total we have 6 number substations. So each substation spacing we have kept at 2 to 2.5 kilometers to maintain the voltage drop and to minimize the cable sizes. This is our single line diagram. You can see here we have total 6 number substations, and location is also well mentioned. At both portals we have a 33 kV substation including 11 kV. So you can see here the 33 kV substation receiving the power supply from grid, 2 numbers, and both 33 kV substation, both portals which are connecting to each other through 2 cable feeders. So in case of one supply or one substation fails, so it will take the power supply through other substation. Similarly, at the each equipment level, you can see here we have provided 2 numbers transformers. From the help of transformer, we are step down the voltage from 33 to 11 kV, and we are providing the 2 number transformer, one working and one standby. So here also we are maintaining the redundancy, and after this voltage is step down from 11 kV to 415 volt. Here also we have considered 2 number transformers, one working and standby. So I have taken some scenario that I will explain one by one. So the first scenario you can see here, in case one complete 33 kV substation fails, then how power supply will come through the other substation. And you can see here our 11 kV substation also connecting to through ring wing systems. So in case of any electrical power system fails, it will take the power supply from other substations. This is a second scenario. You can see here we have considered our standby DG power system also. In case of our both 33 kV substation fails, then supply will come through the diesel generators, and in diesel generators we will get the power supply 11 kV voltage. Why we have taken the 11 kV DG set? To maintain the voltage drop and to minimize the LT cable sizes. In next scenario you can see, if our one transformer fails in 33 kV substation, the supply will come through the other transformers. Similarly, in next scenario you can see here, in case inside the USS, inside the tunnel substation, if one transformer fails, other transformer will cater the complete load. So we have taken the rating of the transformer in a manner, in case one transformer fails, the other transformer can feed the complete power supply inside the tunnel. And in this slide you can see here, inside the USS, if our complete 11 kV substation transformers, both transformer fails, then how power supply will come? Then power supply will come through the UPS. So UPS will take care all the emergency equipment like emergency lighting, signages, and our control system including SCADA and our gas suppression system, including the fire detection. So our the complete life safety equipment, especially who will indicate the indicate and monitor the power supply at the control level. So that power supply will come through the UPS. So this is actually you can see here why we have connected to substation to the dual cable feeders. here you can see in case failure at the cable between two substation, then the supply will come through the other filters. The cable can be fails due to the any breaking of the cable, or maybe due to the any short circuit, or maybe termination losses. So this is our conclusion. We can see here we have taken the 5 points. So the first point already I explained. The redundancy we are maintaining in our this project at each levels 33 kV, 11 kV and 433 volt. And the second point you can see working and standby of configuration also we have considered here. Means we have considered 2 number transformers, one working and standby. In case one fails, the other will cater the full load. The third point also we have covered. Means we are maintaining the redundancy at 11 kV cable fitter also. And in case of complete power supply fails, means grid failure, then supply will come through our 11 kV DC side. So here also we are maintaining the redundancy. And the last point, in case of the complete 11 kV substation fail, then supply will come through the UPS. So all these 5 points we are maintaining the redundancy at each level of the power supply system, and there is minimum chances to failure of the power supply. So this is the actual conclusion for the redundancy at reliable power supply system for the tunnels. At last, actually, this is actually our another expertise. In addition, tunnel portal architecture and aesthetic, and this is our USBR project, same project what I explained to you. These are the tunnel fascia of portals of T48. You can see T49, T74 and T78. With these all tunnels, we have done the complete electromechanical and civil part, including these architectural fascia. This also you can see, these are the pictures, T50, and these are the portal fascia architecture. This is for points. Thank you.
Thank you so much. Having kept very wonderfully the time. Actually, I think we are only 9 minutes in delay over the plant end, and I give back the word to Lady. Thank you so much.
Thank you so much, Andrew. With that, ladies and gentlemen, we come to the end of technical session 6. May I request our chair to kindly step forward and present mementos to our speakers who were there for this particular session. May I request all the speakers to kindly assemble near the stage so that we can quickly have our memento ceremony. We shall start with Mr. Rohit Tilak, followed by Mr. Rakesh Kumar Khalil, Mr. Dhanendra N. Tripathi, Mr. Tripathi, Mr. Dhanendra Tripathi. Can we now have Mr. Harshvardhan Upadhyay? Thank you, Mr. Deshpande. And now may we have Mr. Mahendra S. Rana. thank you everyone, and I thank the chair for very nicely and in time finishing our technical session for the day. Thank you so much. And ladies and gentlemen, with that, we now come to the end of the 2 days session on underground space, the need of the day. And we shall now be moving forward to the valedictory session. Ladies and gentlemen, just very shortly we will begin with the valedictory session. So I request you all to kindly not leave the ballroom. And can I please request everyone to kindly move back towards their respective seats. We are now going to start with the valedictory session. May I request all the people near the stalls to kindly please proceed towards their respective seats. Ladies and gentlemen, standing at the extreme corners of the hall, please may I request you all to kindly shift back towards your respective seats. We're now to start with the valedictory session for the day. May I now request Lieutenant General Suresh Sharma to kindly join us on stage for the valedictory session. Ladies and gentlemen, please may I request you all to kindly proceed towards your respective seats, especially the ones standing on the extreme corners of the ballroom. This is a sincere announcement for all of you. Please step back towards your seats so that we can start with the valedictory session.
Okay, gentlemen at the rear seats, can I request you to please come forward? There are very few of us. Let's see each other's face. Come forward. You've been very patient listeners for 2 days. You're the best of the best. You have stayed back while many others have left. So I take it you are the sincerest, committed and passionate about tunneling. So let's see each other's face as we conclude. Okay, on a serious note, ladies and gentlemen, all good things come to an end. That's the proverbial saying. So with this session getting over, I think we come to the end of 2 days and in a way 4 days proceedings. All that remains for me is to thank each one of you who are present here, and even those who had to leave a bit early and those who are not present here at this point of time. Some friends who are connected to us online, we are grateful to them also. and we will thank them as well. Well, I think my first sincere thanks to all the participants. Special thanks to the presenters, and very special thanks to the presenters who have come from overseas to be with us. If we go over the 2 days program, just get me a copy of the program. So there will be a copy of the program just to summarize on my seat. Program you copy. Yeah, just to recapitulate as to what all went by. So the day started with an inaugural session, and we had luminaries working in the field of tunneling, sharing their experiences with us. It was a very large number, very heartening. And what was even more heartening, that the hall was packed, jam-packed and full. Maybe it's because it was happening after a long time, and the feedback that I got was that most of us were actually waiting for this event to happen, so that we could connect with each other, meet up with each other, and relate to each other. That was the plenary session, followed by a technical session 1 on the subsurface planning, investigation and design, followed by the technical session 2 on the contractual and insurance aspects. Ladies and gentlemen, this is something new that we have added this year, and I think you will all agree that there is tremendous scope here for us to deliberate further. Technical session 3, which started this morning, was on the tunnel and cavern construction technology equipment. Session 4 was the industry special aspects, where some of our industry partners got a very quick time frame slot to update us on their industrial products. Followed by the next session 5 on the urban tunneling, and the last session, which is just concluded, on the innovative techniques. So we've given you a flavor of all that which is going on here. Maybe in our bid to do so, we have exceeded our mandate because everything is happening in one hall. So lesson 1 which I am taking away from here is, next year when we have it, we go to split it. While most of the major sessions will happen here, some of the minor sessions can also happen on the sidelines elsewhere, like it is done elsewhere, so that the people who are presenting here get sufficient time, may get 20-25 minutes. So that's point 1. So that can only happen when we have concurrent activities going on in 2 or 3 halls. You go and attend WTC, it is going on simultaneously in 6 halls. Okay, and it happens in all the international events that everything is not concentrated in just one go. Yes, major topics will be covered here in the central hall. Other minor topics can be covered in the adjoining halls as well. Right. I have a long list of people whom to thank. So if I end up missing out anyone, intention is to cover everyone. Please do not mind. From my side, each and every person who has been with us for 2 days deserves a vote of thanks. Our organizers, especially Mumbai Metro, led by the team member S.K. Gupta ji, we should thank them. I think without their efforts, we wouldn't have been very successful in conducting this event. We thank our sponsors who came up in very large numbers. Okay, the number is very large, so she leaves me a list here. I'm not going to read the list. You are going to read the list as they come forward. On our own staff, we have Sunil Sharma, Kalpana and their team. They've done a wonderful job. Backstage always, you will rarely find them. But I'm mesmerized by these 3 or 4 people who are managing backstage, transport, coming, accommodation, aircraft movement, people from overseas, connecting up here, everywhere. And the staff of Hotel ITC Maratha, I think they deserve a compliment from us. They've been very proactive, they've been forthcoming. I think within minutes they can stitch up things for us. They've been very cordial with us. Ashmita, the young lady who's been with us, very quickly updating as to what is to be, and she's a pro at it. She's managed the things very well. Well done, Ashmita. On the sidelines, we've had the 2 days workshop which was at the MMRDA. Some of you have attended, some of you may not have. It was a very conclusive kind of a workshop. And today we had a sideline session going on. You must have found some of us melting away for a minute. It's not that we were running away from the conference. It was to take part in the young members tunneling association on the sidelines. So I can safely conclude on behalf of all of you present here that our aim has been achieved. We had set out our aims largely to interact, to network, to meet up, to highlight what concerns us, where we need to focus, to showcase to us, to increase our own confidence levels in our own capabilities, showcase to the rest of us, where does I made a small presentation to tell the world where are we moving. The scope that we have in this country, phenomenal scope. The technological advancements which are happening, the open-mindedness that we have in India to absorb technologies, to move forward. So all that is happening. So all this has now come forward, and I think we need to feel more confident about ourselves, and also feel confident that whatever we have done and whatever we are trying to do, we are growing at a phenomenal pace, which is very, very good for us and for our country and for all those who are supporting us, and not only from within our country, even from outside, who are here working with us shoulder to shoulder. We thank them. Meeting in person, I won't need to explain this. Lessons have been drawn home. One more thing that I realized that over talk, that today we have, other than some very routine projects, we have some very high value projects. Very, very high value projects. Next time we should talk about those also. Another event which happened was giving the awards, Tunneling Asia Awards, which is the 3rd edition, which is a good thing we must keep up. And the highlight of the day was the Metro Man of India, or I dare say that one of the most respected person in our part of the world, Dr. Sridhan, was personally present with us to achieve his Lifetime Achievement Award, which was very good. We felt very nice, and that's the way we must acknowledge people. So with that, I won't take more time. I think we've heard each other too much now. So before somebody rings the bell that your 10 minutes are over, I think I should quit. And with that, I personally, and on behalf of our President, Dr. Mangu Singh, who had to go back, I personally feel very satisfied, and I feel very happy. It's really a pleasure to talk to all of you. I had in between gone and met some more people. They are asking, how is the conference going? I said, this conference is great, because now we are also reaching a stage like the international communities, that the tunneling fraternity, the tunneling community in India is coming together. Not to cross paths with each other, to collaborate with each other. There is enough scope for all of us to operate in this space. It's a very wide space. So which is a good thing to happen, that okay, 60-70% of people who are sitting here are now almost known to each other. And that's the way it should happen. Thank you. God bless you all. Safe journey back home. Till we meet again, let's hope and pray that next time it happens in about 2 years and not later. God bless you. Bye-bye.
Thank you, sir. So, ladies and gentlemen, with that, we shall now be starting with the felicitation ceremony of all these sponsors who've been very kind and patient with us for the last 2 days, and especially me, since I've been champering a lot of information here. So, the first we have with us in the co-organizer category is Delhi Metro Rail Corporation Limited. May I request somebody from the team of Delhi Metro Rail Corporation Limited to kindly step forward. Alright, our next co-organizer under the sponsorship category is Mumbai Metro Rail Corporation Limited. We have both Delhi Metro and Mumbai Metro coming. Please, sir. Ladies and gentlemen, can we please have a warm round of applause? The next we have under the platinum category, Lombardi Engineering India Private Limited. May we have somebody? Right. We have Mr. Panseria coming from the Lombardi Group. Our next platinum sponsor would be CISO Softwares India Private Limited. Under the next golden category, we first have Bajaj Reinforcement LLP, followed by SJVN Limited, Satluj Jal Vidyut Nigam Limited. Do we have somebody from Bajaj Reinforcement LLP? No? Then, right, the next would be from SJVN Limited, followed by Norma India Private Limited, under the silver category, we have Argentium International Private Limited. Do we have somebody from Argentium? Yes, we do. Our next would be under the silver category, Stevels India Private Limited. Do we have somebody from Stevels? All right, the next would be Bikat Mukund Bio Industries Private Limited. Our next sponsor under the silver category would be Strons Engineers, followed by PEMS Engineering Consultants. We have Mr. Singh coming from PEMS Engineering Consultants. Our next silver sponsor would be J. Kumar. Do we have somebody from Elkim? Our next would be L&T Construction. Our next from the silver category would be ACOM. Our next from the silver category would be Kasturi Duraflex Steel Fibers. Our next under the supporter category would be Fosrock Chemicals India Private Limited. Concrete Additives and Chemicals Private Limited. Can we now have our kit sponsors for the event, Tata Steel? Our next would be HCC Limited. After HCC Limited, under the same supporter category, do we have Concrete Additives and Chemicals Private Limited? Followed by Ultratech. Now come to our exhibitors. We first have Forbes Marshall. Can we have somebody from the Forbes Marshall team? Followed by Dextra. Our next would be Precision Dowell Private Limited. Do we have somebody from Precision Dowell Private Limited? All right. Our next would be Rory Enterprises LLP. There is? Can we please have a warm round of applause, ladies and gentlemen? We now come to our media partners. Can we please have NBM and CW on stage, please? NBM. Now, our first AIYM sponsor would be Gol Zeidler Consultants. Do we have somebody from the Zeidler Consultants? All right. Followed by Geo Consultant India Private Limited. We have from Gol Zeidler Consultants. Ladies and gentlemen, can we please have a warm round of applause? Geo Consultants as well. And we now have Geo Consultants India Private Limited, RTAIYM sponsor. Can we have somebody from ADO Additives Technologies Limited? Do we have somebody from ADO Additives Technology Limited? All right, with that, ladies and gentlemen, we come to the end of the felicitation ceremony to our sponsors. With that, on behalf of the entire team, thank you for being such a wonderful and august audience. I hope you had a wonderful 2-day time with us, and we hope to see you soon again. Please travel safe, as Sir said, and stay healthy. Thank you. Thank you so much for being a part of this 2-day event.